ain't a wall that walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not down to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man Bills was running through his head. Cheryl probably got it hiding under his bed. Penny up the ante, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes in talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tones chuck the prongs. Burning, breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Bills. What's up, Joe?
TGIFMFs. Going on, everybody?
What's up, guys? We are going to talk a little bit about the Rav and kind of go off topic like we always do and pull in some other stuff into it. It'd be pretty cool.
Right on.
Yeah, I wanted to, real quick, if you don't mind, Joe. I wanted to show this right here just so everybody sees it, and then we'll just move on to everything else, I guess. I just wanted to show this.
Cool.
It's the anode, and it's still fully intact when we're making these things. So I just wanted to get that out there. You know what I mean? Regardless of which direction it was going. We have a fully intact anode. It's just a little dark. You know what I mean? It gets a little bit of red, a little bit of heat look on it, which is not a problem, but there's no loss from it. So it's pretty interesting.
Yeah, so I mean, a couple of points here, right, that we had talked about before. First of all, ideally, in my experience, has always been you want a sharp anode. There's various reasons for that. That has to do with the way that energy leaves the anode. It creates like the turbulence and such that kind of creates a more diffuse state off of the output of the anode. But in this particular case, it was actually a good thing that it's cut flat like that, because if the anode tip was melting at all, I mean, I guess you'd be able to see it obviously too with the sharpened point, but in this case, you could still manage to see that that's a nice square hard edge on that anode that's not melting off. So that's going to be kind of critical to, I guess, where this conversation's going.
Yeah, well, I'll show another picture here real quick. This is the material here. And you can see right there where it goes through. Sorry, you can see right there, it goes through and you got the outside glaze coming in on both sides of it. And I can't tell if this is much different than this when you get it this close. You know what I mean? But there's a little bit darker in there. That's about it.
So it's important to note that with this image is upside down. Okay, so and I apologize, Nathan, but you didn't give any context to what we're actually showing. So what happened was Nathan realized at the bottom of one of his test samples of the ceramic barrier that there was a metal deposition at the bottom of the cathode, at the bottom of the ceramic, and it was still intact, the piece of clay. So we didn't really know what was going on with that situation. But what you could see at the top is like just the general charring and stuff that you typically expect to see when running this type of reaction. But again, what the anomaly was here was that there was a bead of precipitated metal out at the bottom of the plate. When Nathan broke it open, what you could see is that the metal didn't burrow through in a physical effect. Okay, so it's not like a physical hole, but what it did was channel. And we could go. I have lots of talking points on that, but I just wanted to give at least context
Oh
to
yeah,
what we're
sorry.
to what we're seeing, because I don't think that they knew that there was a bead on the bottom.
No, that's my fault. I showed the wrong picture first.
No, it's all good.
So there it is.
And that's no small sum of metal.
No, I don't even think it's metal.
Oh no?
No, it crumbled right away, man. It was like carbon. It was like
Oh, was it? I thought you said it was metal.
no, this is like carbon. I put over my magnet to it, checked it. There's no metal in it. It was just that's why I kept calling it carbon, because it just disintegrated right away.
Okay. So I mean that doesn't really change all too much of what the idea of how this happened was anyway, but there it is.
Yeah. Kind of crazy because the other side, let's see, you can see it right there. Here's the other side. I don't think I got a great view of that one. No, I got a very bad view of it.
Yeah. It's also worth noting too that Nathan is not conducting this Rav experiment the same as Sean is whatsoever. Okay, like there's certain similarities that are there as far as the fact that it's an anode cathode type relationship, and the substrate that it's occurring on. The results are wildly different, and the experiment itself is different, and the mechanisms change a little bit too. So that's important to kind of know.
So let me give you a context to that. Basically, I'm waiting for a power supply to come in with the AC flybacks in it, and that won't be here till the 9th. So I took a single AC flyback and ran it off with ZVS in order to do it. I'm 11 kilohertz different than Sean's got. I do have resonance inside the sphere that's being built. And it's done with the anode being stainless steel, just like Sean does. The cathode, though, is aluminum, like a little pie pan. Okay. So it's a little bit different. Sean has a stainless steel bowl that he uses for his. There's still water in both sides of it. On the first time I got the effect, I tapped the water with the little Q-tip. After that, I never had to again. It just immediately started. So based on whatever that material was that went through there, it ignited the process right away again. So it was like a second that it took to do it. Anytime that wasn't there, it would have to redo the whole entire thing with the water and everything else to get to that process. So the difference in Sean's is a little bit more controlled, a little more balanced in the output of the energy itself. So he's got a 555 timer circuit inside of that power unit. So what it does, it regulates the frequency. So he's getting a real clean frequency that's going on in resonance between the anode and cathode, and it makes a real big difference. So in my experiment, what I did was I took my ZVS and my cap bank, and I was able to change the capacitance as I wanted to get the frequency to change. And that way I was getting closer to what Sean was doing, because I was up at 140 kilohertz and I got it down to 114, you know what I mean? But I'm still off in getting there. So we were at least 11 apart. I think the last time I checked when I got it got down real low. Sean was around 100, and then I was at right around 111. I think the last time I looked. It's closer. The amplitude in mine sucks. Right now, you could see it on your oscilloscope, but you can see the frequency attenuates in resonance. Okay, but the amplitude, how high it goes, is garbage. Okay, in Sean's, you can see it's like this. A much better look in what you're doing. So he's getting a more coherent circles in it. Mine are kind of blasting out everywhere because it's not hitting coherence because the amplitude sucks. So we'll have to fix that a little bit.
Now, there's things that we've been seeing on both sides of what you're doing and what Sean's doing, right? Where we could kind of hammer down some of the key attributes of the process that's occurring, which is critical, because obviously in order to fully exploit the system for all that its potential is, and just understand what the implications fully are more than what we're seeing, there are other things that are still kind of being worked out. And one of the theories that I kind of have, because in Nathan's side of things, the way that he's running it currently, is he's actually done away with the water component of it. And by doing away with the water component, you'd be dealing with exclusively anodic plasma. So, there's only so many types of plasma that could come out of that anode reaction, and it's mainly going to be oxygen and nitrogen at the types of power levels that you're using. Meaning that what you're ultimately stabilizing by bringing that arc into a ball form, similarly, is sort of a one part thing that lacks a core. Now that's not a bad thing, but it doesn't have that separation necessarily. And this is a theory. This is not me saying this matter of factly at this point. But it seems to be a one component circumstance. And one of the major factors that I found recently that I speculate has a lot to do with the magnetic component that allows for the compression to occur, has to do with the interaction between the anode in both cases and the iron oxide content in the terracotta. So you're exploiting the electromagnetism that's induced into the cathode, to create a reverse vortex at the surface level from the point of ignition. And that's sort of like the theory, as far as some of the other things that are more nuanced as to, how you could actually form it with pretty much just the anodic side without the cathode dependence.
Yeah. Well, you got to have the cathode to the pan. It makes a difference because it's part of the vortex that gets created in the center. That's the relationship. Yeah. So
absolutely, the anode needs the place to draw to, and then it needs the reverse component. But in your particular case, because of the lack of electrolysis, that's occurring, it's not adding its own physical component. It's just adding an energy component.
Well, it kind of goes to a little bit of what Bob Grenier was saying, and the fact that this thing starts up right away after it's already been put there. After it's already been used, it works much better. Yeah. Well, this is why. Because it's already depositing something on there, and I just think it's carbon, and that's triggering the reaction. And that's what I think.
And that makes sense. So, the temperatures that the arc is operating at, and the heat that would be exposed to the anode itself, would actually be capable of destabilizing the carbon molecules out of the material itself, and actually propelling the carbon molecules through the arc, and then through the pressure of the arc onto the clay. And then you start basically continuing that, and it becomes like a sandblaster, right? You hit something with a sandblaster, right? It's the air that's moving it, but it's the sand that's kind of moving, right? Now in this case, because it's only it's not carbon particles, it's like basically broken off carbon charged molecules. It's making its way into the clay through the pressure of the anode, and then the draw from the negative cathode will actually pull it through the surface, creating the channel. There's other things that could be happening in the clay as well, like different sinter effects. Okay, because anytime you heat like a porous clay structure like that, there's going to be contraction of the pores that occurs, and in some cases also expansion of the pores. It depends on what the temperature and energy levels are like and the concentration. But regardless of that, it's still enough to force those carbon molecules through the porous structure. And then that's also drawn in by the negative charge, that's why you end up with the deposition of what appears to be carbon on the other side. The other elements that are in the stainless steel, other than carbon, mostly being like, nickel and iron, those are more stable at higher temperatures. So you wouldn't necessarily get the same degree of, ionization and stripping of those molecules to deposit in the same way. So that actually makes sense why you're saying it would look like pure carbon, because it probably was.
Yeah. Well, once it creates a stable vortex, and it's already started, and it continues to go that way. It'll go for a long time. By the way, I had this thing running for 3 minutes, and that's my GVS didn't have a fan on it, and it was a little cheapy deal, so it died after that. But that was the only reason. It wasn't the anode cathode doing anything. It was just my ZVS and the MOSFETs in it needed a little bit of air. That was it. So this thing, the reaction would go quite a long time, as long as you put a little bit of energy into it. So I think one of the biggest points I want to make here is the amplification of this thing. Without it, this whole project's garbage. It won't work. You have to get this thing to amplify. And I saw it in the cap bank when I switched it. I saw as soon as I changed the frequency in it. The frequency gets you there, okay? But frequency just on your oscilloscope, yeah, it's in resonance, but it's not having enough power into it. You got to understand, you'll never be able to put enough volts and amps into any of this stuff to make it work. The only power that you're going to get is an amplitude, okay? That's it, because it amplifies the rings that are going on. So you're putting one ring in resonance, the next ring in resonance, the next ring in resonance, the next ring. It keeps going like that. So it makes sense that the amplitude would do it. And this proves out in the Tesla coils that I did, because when you look at it, I turned down the amount of volts and amps going into it. And I can get that sucker down to 5 volts and get more energy out of the secondary coil just with the wire around it than I can out of the primary driver. And that's because the amplitude is so high. So it creates entanglement when you do that. It is doing the same thing here. There's no question of what's going on. You're building a node in the center of this thing. And once you do that, the actual thing would start to normally vortex top and bottom, but that's not what happens when you build a sphere. When you build a sphere, it builds the vortex in a different way. It's no longer a vortex that then follows around it and comes in like this and starts to go like this. See, that's the difference. When you go from a linear format to a dimensional format, it changes how the operation works. So it matters the amount of amplitude, because that's the distance it goes in to the amount that it goes out. So the amount that it goes in to out. So when you look at your oscilloscope, from the very bottom to the very top, to the very bottom to the very top, that's your amplitude right there. That's F equals 1 over T. Frequency equals 1 over time, which means frequency equals the amplitude over the time. So over the duration of the signal, that's the amplitude, okay? That's really what it is. So you need that thing to go out further and in further. Why? Because it's simple physics. You pull things apart with energy, the vacuum hits, it sucks it back in, right? But it also sucks in all the energy from the environment outside. So it doesn't matter if you're in space or right here on Earth, okay? If there's energy in the environment, it pulls it in. This is the TUFT anode understanding. So if you look that up, you'll see exactly what it is. And it's an anode cathode reaction. Same thing we're doing here. And it pulls in the environment in order to make zones. It'll make a zone in the center that's an old zone. Then it'll go out from there, which is a resonance zone. Then they'll have areas that are filled in with the most energy, okay? And then and ones that go out to positive and negative energy. It's as simple as that, guys. This thing builds out just like that whole process did. If you watch the whole video on that, you understood it.
Now, Nathan does bring up a good point with this. The idea being that you do need that amplitude to get your maximum expansion and contraction out of what we're considering to be the cavitative effect of the RAV itself in whatever form it's coming in, right? To put it into sort of context and perspective and why that's significant, is that we've discussed the different methods of being able to utilize this, with basically the mechanical means being the wasteful option. So while physicists sit there and ponder how they're going to, create a fusion reaction and then use the heat off of that fusion reaction to then perpetuate the same exact bullshit, nonsense, wrong idea that we've had forever. Like, it was great monkey brain idea to get you there, right? But like, to sit there and boil steam to run a turbine to spin a magnet among a coil. Do you understand how wasteful that is? How many points of entropy do you want to introduce when you've just defeated entropy?
Yeah.
Like, I mean, listen, I'm a lot of things, but retarded I'm not. And that sounds retarded to me. Like,
Okay.
and that's it. So what do you want to do? Well, I mean, if you already have a wildly low resistance system, if not eliminated, okay, well, you want to encourage that same thing that makes it that into how you extract and distribute the energy. So that means that you want to be able to pick up coils that are tuned specifically right to where they have to be able to pick up all of the resonance that's coming off of what? The RAV? Yeah, no, not the RAV. The RAV is holding it in. Okay? You want to pull it off of the cavitative effect. You want to pull it off of the expansion and the contraction, because every time it expands and it contracts, it's creating a new waveform that could then be picked up and throw multiple different arrays of coils into resonance that could then actually be captured and stored.
It doesn't even have to be a coil. It could be a transformer wrapped in the same frequency.
It could be. It absolutely could be. You just need to pick up the frequency. And one other thing that I kind of brought up is, however you pick it up, is that you could have a secondary geometric effect. This is a theory, okay? So I'm putting it out there, theory versus this is where we're at, right? The theory here is that however you're capturing it in resonance is secondary to the fact that you actually want a geometric type of physical structure that sort of limits the how far those waveforms thrown off of the pulsing goes, because you want that to then wrap around and reverberate back. So you actually want to create constructive interference, by virtue of what happened. So the whole thing is an amplification system. It kind of works like a bass box in a way, where it's throwing the waveforms in one direction, wrapping it back around, constructive interference, and then it has a lot more pressure at that point, keeping everything at least an ambient high level of energy, and then allowing it to perpetuate. And that's really where it's at. That's where you start taking the little pulse, and it has to build. And it's like Nathan said a million times, these things just don't happen. It just doesn't snap your fingers and bang, there it is all of a sudden. It's not a generator, where you yank the cord, the thing is spinning, and then all of a sudden you have your energy because it's on demand, right? Like, this thing has to build out a little bit, but as soon as it's built out, and then that reverberation situation happens, then you have all your method of pickup, and then your RAV itself actually feeding off of each other into one bigger feedback. This is it. You blew the doors off the hinges.
Yeah. Well, I don't think if people misunderstand this. The plasma is the waste. It's not what you want to build anything on. We already learned that. The heat's the waste. It's a byproduct. It's something you want to eliminate. You want this thing to run at room temperature. You don't want it
hold
to
it
run.
in. Right. You want it all held in. You want it regulated in temperature.
Yeah. See, that's the difference here. A lot of people think, oh, I need plasma. No, you don't need plasma. That's a waste of energy. That's because they separated their systems and they're doing them wrong. That's why they're getting a ton of plasma, and it's absolutely worthless. The whole idea here is to put things in resonance. So you gotta get it down to room temperature. And the only way to do that is put it in a very smooth resonance with a very high amplification.
Absolutely. And when every component is optimized in order to perpetuate what you just said, is exactly what it is, because then it's in orders of magnitude as far as the amplification goes. So whatever's going into create it is an amplification attribute. The thing itself is an amplification attribute, and then what's surrounding it is an amplification attribute. And I go a step further, and we'll open this can of worms a little further. But the material that you build it on cathodically, like if this is the relationship that you're talking about, like that too could be actually optimized to then also further amplify and bring about the greater effect. So that's something that we'll bring up later. But
I wanted to go over this. I think people misunderstand this. We're not building this in the volts and amperage stage. Those things are almost useless in this. Okay, just understand this. What I'm trying to tell you. The higher the amplitude of the resonance frequency, the more energy it has. Why? Because it's pulling in and out radiation. That's why it has energy. Okay, it gets a half-life in there. It has energy. Energy is not always in volts and amps. That's a misunderstanding of it. This is not all voltage. This is not all amperage. This is all amplification of resonance, which is in radiation effect, which means that you're going to have a ton of radiation from this after you build it real big. Okay. But you're also going to have radiant and radiation depending on where your field is. This is the plus and minus of space. Okay. This is exactly how it's going to, build out. So when you start talking about volts and amps, we're going to get this thing running at about 4 volts and less than, 200 milliamps at the same size. Why? Because the amplification's in the resonance, which means that we're building it out in radiation. So just understand that all the entanglement in the whole universe is all radiation. It is not in voltage and amperage. That's a man-made thing. Energy works much different than what we make.
I mean, like you said, with the resonance being the actual energy effect, I mean, that goes right back to how it's frequency just in general. But to digress from that a little bit, the idea here again is that it's the fact that it's in that pulsing state. And there's all sorts of things I could say about that pulsing state. Some of it goes really far out there. I mean, I do believe that Nathan's does operate a little bit different at this point in time, at least, than Sean's does. And maybe it won't forever. But like in Sean's examples, there's just like these repeated examples of things that I'm seeing in very, very high level plasma physics labs reports. It's present right on Sean's table, like literally in air, and for like, aside from the power supply, less than $10.
Yeah.
So say as you may. And the crazy stuff that we're seeing is actually, it coincides with high level physics in terms of not just plasma and energy physics, but the by and large of things. Like when you're talking about higher dimensionality and all those sorts of circumstances.
Yeah, I gotta say this, Joe. You say there's two different effects. Let me just say this, okay? There are two different processes going on. Let's just understand this. The process isn't that much different. The result is a little bit different, okay? But he's still using an AC flyback. It still has to do with frequency. It still has to deal with resonance. It's all part of the same format of this. This is where physics screws something up, okay? This is where they would say, no, it's an atom. No, it's a particle. No, it's an atom. No, it's a particle. And it's like, this is the problem here. You're going to keep naming it different shit, but it's the same process. It's just tuning. All you're doing is tuning it a little differently.
I don't know. I don't know if and you know what? Until further testing is done on both sides, I don't know that I entirely agree with that. And by the way, you got to remember something. My saying though is that hold on, rub your head. My saying is though that it is all the same, and I firmly believe that. So inherently, I agree. The only particular circumstance that like I see different here is that again, like you said, the idea that his is forced into resonance. Yeah, that's a major factor as to the difference. But
Oh my
there's a lot
god.
of visual results that are different too. And it tends to be like if you and I were both to make like chili instead of wings, right? And we come to the table and then like your chili has a little different recipe, tastes different. So, and mine's different, but it's chili at the end of the day, right? It's kind of exactly like that. Like there's different stuff going into it to a degree. Like, the relationship here that's similar is anode cathode and the substrate. That's like what's similar.
Wow. Okay. All right.
I mean,
Look,
tell me.
I can use the same power supply as him, and I can get a different result just by tuning it different.
Absolutely, but that's not the point.
But that was the point. I just told you they're the same thing. If it's just tuning, that's all it is. It goes from one effect to the next based on your tuning because one is in the correct resonance frequency for each thing to be equal. One is outside of that, and as it's on the outside, it has a different effect. The relationship is the same. We get a different effect based on the different things that we do, but the underlying relationship is absolutely 100% the same.
No, I mean, listen, oh no, I'm not disagreeing with you there. Oh
But
no,
that's what I was trying to say. It's all anode cathode, it's all AC flyback, it's all resonance, it's all the same shit. Look, we're just putting a little bit of different sauce in there. That's it. Okay.
Hey, listen, homie. If you want to put corn in your chili, do it all day. Like do it all day. I mean, I'm not about to put corn in my chili, but that's not to say that you doing it makes it wrong. And I think that is the point. It absolutely works off of the same principles, but
Okay,
but the ingredients are certainly different, and the result is therefore different. And that's what I'm saying.
That's why there's multiple suns. That's why there's multiple different ones because everything builds out differently based on your anode and cathode relationship. I'm swapping my cathode for carbon. When I do that, I get a different reaction. Okay.
Absolutely.
So, but that's the point of it. It's what did it start to resonate first? Okay. Where did that energy come from? That's the difference between one sun and the next sun and the next sun. It builds out a different frequency process.
Ulysses, your generosity knows no bounds, my friend, and thank you very much. In all honesty, man, like you being able to give these memberships like you do and get people into our access to see like firsthand and the full resolution and stuff, the stuff that's going on here, just not a small thing in the middle of the screen, and getting the backstage discussions and all that stuff. That's the next level of this. So the appreciation is like, so much, man. It really is.
Yes, I want to say thank you as well, man. That's really awesome, man. You take care of me all the time. We got some good stuff going here, man. We really are diving into this in a different level, behind the scenes a little bit more than we're doing in front of the scenes, kind of holding back a little bit just because I want to see some of the effects pull out before we show everything. But yeah, thank you very much, man. That's awesome. A lot of people.
And you know what? Like for what it's worth, I'll make sure that I get with Nathan, provided we both have time and stuff during the week, to at least try to do like one weekly like backstage discussion that we have or something like that. Like, not all of them are productive and worth being put up there. Sometimes we just banter and shoot the stuff, but at the end of the day, like there should be that resource available to see what our mindset is when we come in here. And if you're a member, I think you should have access to that. So
I just want to give a shout out real quick. It says Traveling Fools, they invited me onto a podcast, man, and I'll be doing that on the 19th. So
Yeah,
It'd
right
be
on.
awesome, man. I'm excited about it. We'll go over there and I mean, hopefully we'll have some more of this, little more of this built out, man. So,
All right, let's ask the audience real quick. Let's sidetrack from rap for a second, although it's still about it. Um, I want you guys to drop in the comments if you've seen the Demystify Psy channel before. Okay.
oh, I know what you're talking about.
Now, if you've seen the channel before, right? Like they have a decent following and everything like that. Bit bigger than ours, but not exponential, but bit bigger, right?
Mhm.
I signed up to have a chance to be able to present some of this stuff on that particular channel. Okay. Now, here's the thing. I have figured a way to describe Sean's rap reaction. Okay. The entire theory in 60 seconds. No, get your head around that for 1 second. Mr. You know, and word salad, etc. Yeah, all I have to do in order to be coherent is to put my words on paper. It's it. Like it because the other stuff doesn't come out there. So I was able to do it. Now here's the thing. In order to fit this entire theory into 60 seconds to try to get a bigger slot, okay, I had to be big wordy and talk fast. Big wordy and talk fast. But I did it. I recorded it. It's 59 seconds, 0.8. Okay. Case in point is, do I use the big words and talk fast, or do I just give the basics of it, plain language, and let the curiosity tap the rest of it out? Like that's the opinion I want from the chat. So
Yeah, say it in the language, man. Talk to them.
do you have the
Because they won't
soundbite? You want to play the
yeah, give me a
soundbite?
second. I gotta make sure it'll play. Sorry.
All right. You can play the soundbite if you have it.
Okay, hang on.
Both
hang
if
on.
possible. Yeah, okay, buddy. In 60 seconds, wait until you hear what I've condensed into 60 seconds.
Give me 1 second. I'm over here.
Pro
Push a
flow,
button.
take my time. Okay. Yeah, Ashton was just on their channel also. Yeah, I saw that the day I signed up.
Oh, that brought me back over to here. All right. Hold on.
Yeah, you're gonna have to back up a little bit. We talked a lot.
No, I know. It when I clicked it over, it went backwards. Hold on. Give me 1 second. Let me look for this, and then I'll put it up. Oh man, where is it? Come on, I just had it.
That's a good point, Elijah. You know, it's the way that I put it is that I have the keywords in there. The explanation is dense as hell. Okay. But it exactly describes exactly what I'm trying to relay. So if they don't understand it all, like let them be curious and ask the questions, right? Sort of how I thought about it.
Okay, Joe, tell me if you can hear it.
To create sustainable, self-organized, high-density cavitative plasmas
Yep.
in air at atmospheric pressure by creating a physical bifurcation of the differentials by virtue of the initial configuration. The system creates an asymmetric equilibrium by exploiting the natural properties of a semi-permeable insulative membrane that allows for the hydrogen plasma to form intermedia without combustion at the uppermost surfaces of the membrane, which is then drawn out of the membrane and contained by the anodic bias at the surface, causing plasmatic zoning and the anodic side of the membrane. As the density reaches critical, the zones chase to combine, causing a rotational energy vector, thus a magnetic component. This leads to a parabolic condensation of the anodic plasma to swoop around the hydrogen plasma in a vortex. Greater compression pinches the vortexes, collapses into a toroidal sphere with the hydrogen plasma in the center state of compression.
Wow, that was a mouthful right there.
Yeah. And I did make some changes to it. But yeah. Like I made a handful of changes to it, but like the main change I made was instead of under pressure, is it's in the center in a state of resonant cavitation. So I think that's what I think that's what hits home with it. Yeah, but that's exactly what it is. And in proper English and slow mo, what I said was to create a sustainable, self-organized, high-density cavitated plasma held captive in air at atmospheric pressure. This is accomplished by creating a physical bifurcation of the differentials by virtue of the initial configuration. The system creates asymmetric equilibrium by exploiting the natural properties of a semi-permeable insulative membrane that allows for the hydrogen plasma. My eyesight's not that great. Allows for the hydrogen plasma to form intramedium at the uppermost surfaces of the membrane without combustion, which then is drawn out of the membrane and contained by the anodic bias at the surface, causing plasmatic zoning on the anodic side of the membrane. As the density reaches critical, the zones chase to combine, causing a rotational energy vector, thus a magnetic component. This leads to a parabolic condensation of the anodic plasma that swoops around the hydrogen plasma in a vortex. An increase in the magnetic field compression pinches the vortex, collapsing into a toroidal sphere with the hydrogen plasma in the center in a state of resonant cavitation. That is the entire theory. Bang. That's it. First shots.
Wow. That's awesome, Joe.
Yeah. It's something. It's a lot of words.
Well, they said they wanted it quick. You got it in there.
Well, then they said, well, they're like, you have to tell us, like, you know, your theory in 60 seconds. But then they disclaim it. They're like, but don't think that you can, like, don't even try to explain your whole theory in 60 seconds. It's like, listen, motherfucker, you challenged me to something. You gave me a minute to tell you about, like, you know, self-sustained plasma, self-organizing in the state of cavitation that could then be used for energy distribution in 1 minute. And we know how to do it, and I know too much about it because I've been looking at it for looking at like nothing but this work and things I'm interested in. Not going there. You know, like for like weeks on end, that's all I've been doing is those three things.
Yeah.
So like work, and then this mostly while I'm working too, and then while I'm awake, and then other than that, it's just taking care of my other two needs as a human being. You know, like basically eating and fucking.
In that order. Oh, it's so funny. Yeah, you had to make it as short as possible. Yeah, get it in within the minute. Yeah.
Yep. And you know, like I think that the keywords got in there. I think that was the point, right? Because first of all, I'm not going to give an opinion on them. That's in distaste. They seem very excited about what we're doing without mentioning what we're doing, and I'm tired of us not being mentioned for what we're doing.
There you go. Hey, we got 2 opportunities coming up with them, and then also just a shout out again to Baker over there. He invited me on to Traveling Fools thing on the 19th of next month, man. So we got a couple opportunities to get it out there.
Yep. Well, you're a sure thing. Mine's got to get picked out of a hat.
Huh.
I got my fingers crossed.
I hope you do well, man. We get it out there. You know what? It's the point of, regardless of what internal arguments we have, the fact of the matter is we all believe that this is the next source of energy or the next great thing that you could do out there that's really going to bring some of the physics all together, that make it more understandable for people. Because when I go like this, man, I'm doing string theory all day long. It's just they do it in 2D, so how the hell would you know? You know what I mean?
Yep. I agree.
They talk about in resonance, but how do you know what the heck that is? You know what I mean? People doesn't understand where the radiation comes from, but Joe and I got zapped with a bunch of radiation playing with light bulbs. You know what I mean? Oh, yeah, dude, I got it pretty bad.
All right, all right.
I
So
felt it for weeks.
check this out. What I want to do real quick is I want to throw up and I want you to add in too, please. Some of the differences in the observations that we're seeing on between yours and Sean's. Okay. So we could understand the difference as far as like what the observation currently is. And I'm not talking about the scope observation. We all know at this point that there's observations that are going on that are just beyond the measurement. Okay. So what I've seen so far, yep.
Go ahead. You go
What
ahead.
I've seen so far on Sean's end, right, is his is more contained than Nathan's as far as its stability is concerned. Okay. And by stability, I mean its whole formation. Okay. And then the observation that it is locking in whatever is inside. Okay. So we could actually bypass the whole, well, what's in there situation for a moment. But his isn't bleeding light the same way and in that kind of fashion. So Sean's is very, very condensed. And as you can see, for the type of light emission that is being put out of that thing, which is much brighter in person, I'm certain, right? There is a disproportional amount of environmental illumination that is observed. And what you do see in Sean's frequently, okay, as well, is as it's at the greatest level of expanse, okay, you get the flash. And the flash is not entire environmentally. The flash is generally laser flash. And I say laser flash loosely. I don't mean actual laser. Okay. What I mean by that is it's directional and not 360 degrees. Okay. It's generally biased to one side or another, but it will flash as it reaches mass expanse. That's Sean's. Okay. Now, Nathan's, on the other hand, is much brighter, much brighter. However, the light escape out of Nathan's is also much greater. And what you will realize, and that we've discussed, is that Nathan has regular laser events. Okay. And when I say laser in that circumstance, I mean actual laser events. Where there is coherent light being produced more or less through a virtual Kashmir effect. And that virtual Kashmir effect is actually making the light a coherent wavelength. And then you could actually see the color, the specific color of that wavelength at its point of projection with nothing in between. Sometimes you'll get these ray beams out that are associated with it, but generally speaking, you will not see the actual emission of the colored light. You will just see where the colored light hits, and it's actually happening regular. So that's on that regard, the light emissions regard. Yeah. So I think that that's actually the most significant difference, because that goes to show the level of containments and stability that are going on. I obviously don't think that it's ideal to have the leakage. I think that having it contained in the highest state of expanse and contract is probably the ideal circumstance for the application at hand. That's what I personally believe. But that doesn't mean that Nathan's in its current state, okay, if exploited further in this direction, doesn't have its own properties that are far superior to the other configuration. And I do think that the reason that this is happening on Nathan's side, and this is total theory, okay, is that it lacks a core differential. That's what I personally think. So I think that that's up for debate, but I think that, Sean's is comprised of two separate and oppositely charged plasmas that are brought together. And I think Nathan's is one plasma, one charge, stabilized, the best that it can be, and then in a state of quasi compression. And because it doesn't have anything to necessarily squeeze against other than itself that presses outward on it, that's why it ends up leaking. That's my belief. But again, this is a loose theory at this point. Still working on it.
Looking for a picture real quick, Joe, so I can
Please.
explain mine. So, oh man, it was one you sent me too. Put me in my downloads. Here it is. Now I got it right here. This right here is the difference. This is an effect I'm getting out of mine that Sean isn't getting. You see that little light right there?
Yeah. So that was there in the original photo, but through, again, non-destructive, non-invasive photo enhancement, manual photo enhancement, this is what we were able to discover, is that level of not only detail but also the color differentiation as well. About that anomaly.
Yeah, let me get this other picture so we can see it. I don't know if you can see that right there now. Share that one. Here's where it is in the actual picture. So you can see it just floating there. Now, this I think is one of the most important things because you can see the reaction of the anode cathode, right? It's going crazy. There's no question about that. We're a little more destructive interference here than coherence altogether. Okay, I agree with that. It's what it's doing when it puts out this little thing here. You see, it's hitting some kind of field, and I could tell you it's doing it because it's almost 50% between the anode cathode relationship and outside of the pi tin. So we're seeing that. So in order to open up any kind of wormhole that does not have a receiving body to it, this is what you're going to need. It's going to have to shoot out like a laser. So the effect here, could it be called a laser? Could it not be? Either one at this point. We're not definitive in it.
Yep.
But I just want to show this because when you see this, how do you get to open up the other end? That's the question. When you have something in resonance that's going like this and you want to create a Einstein-Rosen bridge, how do you open the other end? And this is the answer. Go ahead.
Now, in this configuration, I agree that is the answer, but in other configurations, there's other circumstances that exist. Okay, and it's been my guess at this point that both in this reaction, but more in Sean's reaction, just because the differentials are more pronounced. There's more parts. Okay. What I believe is that what's happening on this end that you're observing, okay, is actually happening within the clay, like in the inverse way. Okay. So the same as the anode has the draw on the cathode on this side, and that's what you're seeing. Well, the cathode has a diffuse draw on the escaped energy from the anode. Again, this is a game of differentials, which is why in my description I said, by virtue of the initial setup, a bifurcation of differentials, you got to realize something, that you have a diffuse cathode, okay, and you have a focused anode. Okay, so right there, that's a differential. You have diffuse energy versus focused energy. That's a big deal, But it goes on. The idea here is that what you're seeing here is actually happening in inverse on the cathode side. So there's always a relationship. Now, as long as the anode and the cathode are making some type of connection to make this opposite thing happen, that when the relationship breaks between the anode and cathode to sustain the wrap on the top, okay, that there's still a form of entanglement between the top and the bottom. Now, in Sean's, in that case, it's my opinion, at least at this stage, and I could go on and on about the stages, where it is and where it can go. It doesn't matter. Point is that his RAV doesn't necessarily form, okay, until a certain level of the moisture, right, is actually eliminated from the top surfaces. Okay, so once that moisture level is eliminated from the top surfaces, it breaks the anode and cathode connection in his. Okay, and what you actually see from there is the emanation rise up from the clay because it's in direct relationship, but the only way that it can be seen is through the lens. Okay, which I've explained before. Now, I did go further because I've shown Nathan some photos, and I have more photos. We could share it next week. It'll be worth it because I'll do more. But what I've done is I've created centers of each photograph that's taken. Okay, I've put a cross section to mark the center, to zone it out, and I put concentric rings to represent the curvature of the convex lens in which is being reflected upon. Okay, and then I chart the relationship between points in the still and the movement of the relationship central to the RAV and central to the lens flare. Okay, and what you notice is that there's a correlation, but not a relationship. There's a correlation, but not a relationship. And what that says is profound. What that says is that you're seeing something that's not there, that's in relationship to something that is in frame. You can only see it as far as the relationship is concerned. Okay, it's also a reflection of it. Okay, and it's virtual. Okay, it's a virtual hologram that can actually be projected out if you do it the right way. So what I mean by that is that if you actually reflect it, but also let it go through at the same time, aka like one-sided mirror, okay, you could actually project that emanation out in the distance, and it's still an entangled piece. And that's what's crazy about it, is because it was a holographic entity to begin with, and all you're doing is moving it out by virtue of reflection in our dimension. It becomes very, very mind-breaking, but it's actually proven in certain physics papers in laboratories to work exactly that way. But they don't go into the dimensionality aspect or the entanglement aspect of it. But that's the observation. It's inverse and moving directly in conjunction with. One thing reacts, but then the other thing doesn't necessarily react, except for in its size and proportion, because that's the relevant attribute upper dimensionally, because that's where it comes from. So it's all sorts of stuff. It's like, but when I mapped out the lensing of it, I knew immediately that one thing lensing doesn't do is create three-dimensional holograms of something that's in motion that doesn't have a direct representation of the initial component that's creating it, and that's what we're seeing. Like, and when I say that's what we're seeing, I mean that it's like clear as day. It's like not an opinion. I show you right now. It's like a sphere that's popped in the opposite direction of the like. It's just beyond. It's beyond. It's wild stuff. Yeah, reflections are tricky. I know. But the thing that makes reflections not tricky, okay, so there was one that I sent you. I have a bunch of them, but that's a great example. Okay, you could see that they don't fall in the same rung of the concentric rings. Okay, that they're not in a symmetrical proportion to the center, and their position of the lens and the what do you call it, sensor. Okay, that the shape holds some similarity, okay, but that the differentiation here is like that there's a geometric 3D attribute that should not be present. and that's it. And it goes further than that, because there's internal geometries to that particular sphere too. So it's more than three-dimensional. You're actually seeing a four-dimensional thing in 3D.
That's cool.
Yeah.
So I wanted to show this to you, Joe.
Yeah, let's see.
What kind of laser did you say we were building? The only one would work?
Yeah, I mean, I said that there's a Kashmir effect, and that you probably be running into like red shifting. So red shifting, like in infrared spectrum, and well, what is that?
We're looking at one of them. You can clearly see the lines of it. It's exploding out like lasers, okay? Or I would say it's imploding in. I think that this is a misunderstanding. I think the anode is pulling into the cathode, or I should say the cathode is pulling into the anode in this situation. But you can see the laser beam coming out of it. Regardless, it's going to different colors. And here's the thing: I showed a picture earlier. It showed the rainbow in it. Okay, there's no question it was there. Okay, I could show it again if you want. It's got the rainbow in this thing when it builds out. That's the thing. You say it's just one reaction from a laser, it's all of them. I don't believe in any way that it's just one. So I
Right.
think that's one of the differences. Hold on, let me find it real quick because it's very clear when you get it. We have this thing busting out in all the colors of the rainbow.
Yeah.
Okay, they're all there. It's not like it's not there. So which reaction are you looking for? Which gas are you trying to build? See, the relationship between the anode and cathode was built to gas, and I keep saying that people are understanding it. That's why all the
Right.
colors are there. That's why
So that's
all of
not
them are
just
there.
to be clear to people, like this is a known phenomena, okay, in plasma physics that does not happen in open air, okay? This is not a lens effect. This is a lensing effect. And that's the difference. You know, when you have all of this torsion contorting the escaping energy and then basically pulling it into certain, configurations, this is what you end up with.
Yeah.
That's what you end up with. So every there's certain things. Is it a lens? Is it but lens and lensing, same exact thing. It's just happening energetically as opposed to optically in certain circumstances. I'm going to excuse myself for just 1 minute. I'll be right back. I apologize.
Not a problem. Yeah, one of the reasons, guys, the reason I'm doing this thing and getting it to work this way is I want to push the boundaries of what Sean's doing. He's already established where he has this thing, right? And how coherent it is. But what happens when you add something different to it, when you change it? See, a lot of people don't do that. They get to the happy place and stay there. I don't stay in the happy place, guys. I'm going to push this thing. Why? Because I want an Einstein-Rosen bridge. And the only way to do it is to dial this sucker like a Stargate on one side, put another one over here and dial it the same. But in order to do that, you're going to have to be able to tune the thing. Okay? You're going to have to be able to set it up in two separate systems and tune it to one another so that you can get this thing to build in there. And it's going to build just like a laser between it. Okay? It's going to have a vortex that goes like this, and it's going to build right in between it. And we're going to make an Einstein-Rosen bridge. And we didn't have to bend space-time at all. Okay? So you can take that whole thing and throw it away. There's none of that going on here. We're just creating a wormhole through space. Okay? But we could do it with these things as long as we can understand the tuning. You see, that's why I push things. That's why I tune things. That's why I put different things in there. I want to be able to change the capacitance and amplification in order to make the Rosen bridge, because without it, you're not going to. Without both things in separate systems, you won't do it. I tried to split the anode, didn't work. Okay? It doesn't have enough energy, and if you put too much energy in it, it destroys itself. If you put the thing two separate things, but you keep the same resonance, it's no different than having a pillar coil and a secondary coil. It's the resonance between them has to match. Once it matches, now you go from a three-dimensional object doing this back into a linear effect. So we can make the tube again. Okay? We're changing geometries like crazy. We had a linear effect between the anode and cathode. We went into a three-dimensional sphere. It starts going like this. Now we're going to go back into a linear effect to get over to the three-dimensional objects doing this. It's all entangled. Okay? It's perfect in what it is in the understanding. This is going to be a physics phenomenon if we can pull it off. If we pull this off, okay, and we get this thing done, you're going to see the first one in history ever made. At least from us, I should say. Not that the government hasn't probably already done it.
Yeah, I was going to say they already figured this one out, but guess what? From anything that reaches the public,
yeah, for us, yeah,
we'll be there. and I agree with that. That's 100%. Yeah, I mean, there's a lot of different directions to go with the same exact thing because at the end of the day, and I said it, man, it's all the same. So like what you were trying to achieve or what you did achieve to a certain degree, with coils and then if you want to talk about like the Tesla coils or Uden coils or whatever it is, you want to talk about geometry coils, or rodent coils or the different mechanical ways of creating it or even like, and I hate to say this, but like something as simple as flight. I know I brought this up last week, but I think that in context, it's relevant to bring up again. What does flight do as far as like this most simple aspect of it, right? You have a rotational force, one vector of rotational force creates a high and low pressure. And then what do? You split that high and low pressure one more time into a second high and low pressure. So the first, the second, and the third. And once you have three, then you're free. That's the way it goes. 3 and 3, right? The stability comes by virtue of the first and the second creating the third. Now, that's how this is got. This is how it goes. But this is exactly how flight works, and it's exactly how all stable things operate. It's just about the three motions, the differentials, the separation, then the relationship after they're separated. And that relationship not being what they are together, but what they are being separate. And, we mechanically exploit the same exact principle in every aspect of life, but try to apply it to energy and, or the world at large when it comes to anything non-mechanical. And then all of a sudden you're a witch. You can't reverse entropy. You can't reverse entropy. You can't do that. You can't. Well, what happens when you take opposite things and you put them on two sides of a wall? You break them down into their most pure components of opposites, but then you introduce them coherently, right? You introduce them controlled and coherently. When you do that, what you notice is something that is a second phenomena, which is if you think about a sphere that's also a torus in the center, okay, your north and south pole, right, are at the top and the bottom, right? Your north and south pole opposites attract on the outside of the sphere. But guess what? When you move those same poles geometrically internally, the forces that be actually repel them. You see? So what ends up happening? Well, you end up having a north-north situation where the north on the top, but the north on the in are repelling each other, but then the north and the south that are pushed in, because the same thing's happening on the other side, are pushing away from each other. What does that sound like? Does this sound right? Well, what creates in the middle of your central north-south pole, your central one, the one that works inversely of the ones on the outside? What happens then, motherfucker? Well, what happens is that you have a null zone. That's what. That's what happens. Oh, there I am, barely graduated high school, making sense of it all for people. Come on, like it's all there. When you see the connection between this, that, the next, and you realize that, they could tell you that it's whatever that phenomena is where you see relationship and everything. Well, listen, when you could coherently and logically explain exactly why it is the same, well, that kind of falls apart, doesn't it? That's it. You could see whatever you want in anything because it's generally all there, except for in the most extreme cases of dysfunction.
So I just wanted to point out, we were talking about differences. I didn't say a whole lot about it, but I just want to say this. Sean anodes is not getting hot. It doesn't have the color discoloration on it. And it's because of the resonance itself. he put it at room temperature resonance, and I don't think anybody understood that when you looked at it. He put it at room temperature resonance without even knowing it, and there he went. Okay, now it's still hot, it's still everything else, but it has to do with the anode itself. So if that's a spark gap, okay, he brought down the temperature in it so this thing would move more smoothly. Okay, that's the understanding here. That's what we talk about when you take a system with a spark gap and you put it into the correct resonance and balance it. This is what happens. It brings the temperature down. Okay, you can see it in the reaction on the anode because it's not discolored. Mine is just completely discolored. Okay, because the heat's everywhere. It's blasting out like the sun, man. That's just wow.
You
know
can
what I
see
mean?
it in the photos, and you
Oh,
can
yeah.
see it on your plate. You can see it on your plate. Your plate's marred up to shit, whereas John's plate looked the same since he's been nuking it. Like
Yeah.
he burnt it up a little bit at first, but like ever since then, it's just been running.
But this is one of those things that just shows you what's going on. It's telling a story. Well, by doing it both ways, it's telling the story. If we did it one way, it
Absolutely. I
wouldn't.
agree. Because guess what? I hate to say it, when it's all caught up inside where it should be, you don't see what's going on. Like that's it, plain and simple. You don't realize what's happening on the inside unless if you bring the inside out. By letting the inside out, you're seeing it. It's happening. There it is in full brightness, in full glory, with all its lasers and it's nonsense and it's burning things and literally like forced tunneling, of material deposition. That, by the way, when Nathan says that I think it's carbon on the other side of the plate, I just want to be the one to introduce to you a couple of things. Okay, first of all, there's no carbon in the clay that he's using. There's none. It's all oxides, silicates, and random, like mostly oxides and silicates. That's pretty much all that's in there. Okay. In the air, if you heat carbon dioxide in the air up too far, all it does is split the CO2, okay? But it's not going to take the carbon along for a ride. It's just not. It's going to split it, and it's not going to turn into a plasma. The oxygen will. The carbon will not. So it's not taking that ride. So you know that it's stripping the carbon ions right off the steel and then literally hurling it through the clay. And yeah, is there sinting and stuff like that of the clay? There is. I'm not saying that there's not, but sinting should make it harder for it to actually permeate, but that's not what it's showing. Fact is that it's creating a channel. So it's capturing it, and that's unsurprising because as soon as you charge the carbon from the anode with a positive charge, that whole entire clay piece is the cathode. It's going to sit there and accumulate right exactly where it lies, and that's exactly what you see. It's really quite fascinating and incredible because it's taking larger parts of matter and depositing it on the other side of something. It's quite incredible.
I just want to say thank you to Yanni. Thank you. I appreciate that.
Good man.
Real quick, yes, Sean, I am using the ZVS, and yes, I am using a flyback, but it's not a DC flyback. DC flyback I tried first, didn't work. Has to be an AC flyback, just like what you're using. And by the way, Sean says 30K to make it bigger. I'll make a bet with you, Sean. Okay. I know exactly how to make it bigger, and it has nothing to do with the energy put in. Okay. And I'll say it one last time, and I'll let it go. Okay. The amplitude is from where the actual sine wave comes in, okay, in resonance between the bottom portion and the top. That distance right there is your amplitude, okay? That right there has to increase as the energy decreases. So 30,000 volts, yeah, it may make it bigger like a little bit, but I'm going to get the same size just by doing the amplitude because my amplitude was like this, and it pulled out this thing that's shooting lasers everywhere. Just understand that this was my amplitude. I was able to take that reaction from 15 volts down to 8 volts. Okay. You saw that thing blowing out all that energy at 8 volts. Okay. Just understand this. When I get that amplitude and that sine wave goes all the way up and down that oscilloscope, say good night, man. it's going to be a nightmare in there, and it's going to grow big. Why? Because in a 3-dimensional shape, your amplitude is like this. It's what's doing this. That's your amplitude. Okay. That's why it's different, because the amount of energy in there just makes the plasma thicker. You know what I mean? But the amplitude itself in the resonance makes it do this. That's my opinion of it.
Yeah. I just kind of want to throw in there, and I don't disagree with that. Like I know that you're right. Like what you're saying is correct. I do think that there's analogous ways, but like I really think in order for you to get to that point, I'm going to be straight. Like you need some kind of core, like you do, and that's my opinion on it.
I
Because
need some kind of what?
core to it. It needs
Core?
some kind of core. Yeah,
What
because
do I need
right
a core
now,
for?
well, like for instance, Sean's has a core. Whatever, like, and we could argue it up and down. It doesn't really
Mine
matter.
has a core.
Whatever sort of cathodic deposition is occurring ends up in the core of Sean's. It doesn't matter how minimal. It doesn't matter whether it's sustaining or not. But there's a differential that exists in the core of Sean's, whereas like yours, I think lacks that differential core.
Okay. Let me stop right there, Joe, because I'm going to tell you
Sure.
it has a core. You can't see it as well as Sean's, but it's there. Now look, see this spot right here? That purple spot?
Yep.
See the green inside of it? The core is right there.
So what's the core comprised of?
You're being blinded by the light. You can't see the core through the light, all that extra light going on, but it's there.
Okay, so but what is the core comprised of in your case?
It's the same thing as Sean's. Mine's just a little different. You can still see it there. Look, I have too much light going out everywhere. Okay. By doing that, you can't see that fourth dimensional image going on as well as you should, but it's still right there. Okay. It didn't change. The core's still there. It didn't change whatsoever. It's just you can't see it as well. And I'll agree, the null zones in this are much different sizes than Sean's. And it has to do with
there's a big difference there. Is like his core is like very established, and
you're getting blinded by the light. I think you're getting blinded by the light. They're both.
I mean, it could well be. I've definitely spent more time just because Sean's been doing it longer too. I've spent a lot more time studying what's going on there than I have here. But that was sort of one of those sort of things that kind of came up was what's in the center, what's doing. I mean, I wish we had infrared of this also. I think that we would see actually a big difference between Sean's and Nathan's in this context.
I
Like
have
a
an
big
infrared
difference. But
both Sean and I have an infrared camera. Okay, Sean said it didn't work, so I didn't try mine. But I will do it for the next test.
well, guess what? If it didn't work, it's the best. Well, first of all, it might work on yours, but if it didn't work on Sean's, Sean, I know you're there, and good to see you, buddy. You understand that it not working on it is the point. You get it, right? Like you need to, like that needs to be out there because that is evidence. And as soon as we stop playing the game of I didn't get a reading there, but I would have suspected I got a reading, but I didn't get a reading, so therefore it's invalid. That's horseshit. We need to stop that train of thought. That's a bad train of thought. That's the disease. That's the disease. That's the black matter, the dark matter. That's what it is. So you got to look at what's missing because what's missing is important. So please, by all means, that data imperative. Sean, if you point your infrared at this and you're not getting a reading beyond the ambient environment, what does that say? That says way more than if it was differentiated from the ambient environment. Like, can we understand and realize that? Like, the thing is capable of melting clay at the surface in certain circumstances, and we know that the core is hot, but yet you don't have any tangible escaping heat. Well, isn't that the point? Isn't that the point? Because we have all the light that's supposed to be emanating throughout the environment, but it doesn't. It's compressed, right? We already have this super bright light source that should be lighting up the entire environment, yet the environment's dark. How come? Well, same reason that the heat's not getting out. Like, that's evidence, is what it is. So that's stuff that we need. Like,
Okay, I want to show this, Joe. This is Sean's power source. Okay. I need to clear this up because there's a lot of misunderstanding and flybacks. Okay. Okay. Those right there are AC flybacks. 100%, no question in my mind. Okay. What I used was an AC flyback. Okay. A different look to it, but it's the same thing. What's going on over here in this area, to the side of it, is simply, you could see the 555 timer right there next to the blue thing on the bottom right. You can see that it's running almost like a ZVS. There's not much difference here. And that's all that it's doing. It's modulating frequency inside of all four of those flybacks. Okay. That's what it's doing. And it still runs on the same way. So if you look at the opposite side of the big white part, where you see the little bobbin, you're still wrapping that bobbin the exact same way you do in the thing that I'm doing. Okay. There is not much of a difference. Okay. The difference is how consistent his frequency comes out because of the 555 timer chip. Okay. I can tell you that right now. This is what is going on inside his. So when we get in the chat and stuff, it's not DC is what I'm using. I'm using AC. Okay. There's only two wires coming out of it. You can see up here the red wire, and then there's a black wire that comes out the bottom. That's all AC flyback. Okay. There's no question. So he says he cannot handle the heat, Joe, on his infrared.
725 is low though, man, and you know.
Okay, hold on. Give me a second. I want to show this.
What if he backs up so it's just a smaller exposure of the heat?
Well, I think you could do that and also change the color format in the camera.
I was going to say too, because like realistically, if it's over 725, it should be overexposed at the highest level. So,
yeah, I think pulling it back and we'll try different things and see if it'll work. I'll give it a day, work on it. This should show you this is a cheap setup I have right here and what we're getting. You can see the flyback here. It has two wires coming out of it, just like Sean's. It still has the wrapped right here on the thing, and it still goes into a GVS, which I can add frequency if I wanted to. Okay. I can basically go over and get a frequency generator and connect it right to it and change the frequency in anything I want. Okay. The differences of that part is not a lot. I'll be honest with you, my setup would be much faster in fixing everything because I control the units. So those of you who don't know, I work with a bunch of high voltage and I can change the frequency going in on that side. I can change the capacitance to change the frequency. I can change the capacitance to change the amplitude after I change the frequency over here if I wanted to. Heck, I could take a Tesla coil and put it into the third component and change it in there as well. Okay. There's not much I can't do with this thing. So we can fix this no problem. So,
yeah. So apparently it's 752, but like obviously I don't want him to harm his sensor of his device, but like at the same exact time, if you're further away from it, generally speaking, the amount of the sensor that should be exposed to it should be very minuscule. And if you only do it for a quick, we don't need video. We just need, a flash.
Pictures. You need the pictures more than the video. No, you need pictures.
Exactly right. We just need pictures. So, you're only exposing it for that fast. And I mean, I can't say for what model you have in particular, but I know people with them that have like legitimate like firefighting tools and things like that work off of IR. See fire through windows and so on. I mean, it has a certain max temp, and it's much higher than 752. I'll tell you that. But it will only overexpose the areas you know that are above it. So it's not so much a harm the sensor situation as much in that case as it is you're just going to get a blown out view. You're not going to get a good reading necessarily, but what you're going to get is the idea of whether it's 752 plus or not.
No,
And
Sean's
where
gonna pull the camera away a little bit and see what he gets. I'll do the same thing. Well, one thing I will say is this: if you use OBS as a software when you're recording something, instead of just doing it to your phone or to your camera, but you hook it through OBS, then you can display it on a screen beside it, or you know what I mean, or back somewhere, and then you can see the physical reaction of the camera right away. Like I got a 52-inch TV over here, I could just see the reaction of the plasma and what's going on and how it builds out. So I'm able to tune it a lot better. I'm able to see the whole full picture of it right away, not having to go back and look at film or you know what I mean, something like that. So it makes it a lot easier. So by the way, real quick, Yanni said didn't know the difference between AC and DC on the flyback. Here's the difference. DC flybacks have the pins on the bottom. You'll find a bunch of pins on the bottom. AC flybacks generally do not. Okay. There are hybrids that are out there that have pins on the bottom and they have the two wires coming out of them. That's a hybrid, but that is not something you're going to run into very often. Sean ran into one not long ago, but 90% of the stuff coming out of your tube TVs that was done in the 90s, that's all DC flyback. If you want an AC flyback, you just look for a white one with two wires coming out of it. And it's that simple. So hopefully that helps.
Yeah, I'd like to know more about what Elijah's talking about the endothermic Gibbs reaction. One thing that I've been noticing in the small amounts that I've been kind of researching beyond my analysis is that doing what's going on here has all sorts of chemical reaction implications, as far as the stuff that could happen interactively between what becomes plasma size as far as the material is concerned and how it mixes together through the anode cathode reaction. So they're for one thing that I kept on reading about was actually suggesting that you do not use sodium chloride as an electrolyte, okay, and that you don't use an electrolyte solution for your cathodic reaction in general, just because that it'll actually break it apart into its constituents and release chlorine gas, period, once the plasma collapses. So what you end up with is you end up with chlorine element in your plasma, but as soon as because you're not stripping apart the chlorine into its electrons and protons and all that stuff, you're not breaking it down to that level. You're just turning it into a plasma. Once the charge is gone, all you have is chlorine gas, for instance, from the salt, because it'll break the sodium away from and the chlorine away from the sodium. And those sorts of things can happen and do happen, but at such small levels that it doesn't really matter. But when it comes to actually combining different elements and different compounds and stuff, well, that could also happen in these reactions too. So that's sort of one of those things just to bear in mind. That could both be a positive and a negative. And that's why you have to be careful with the materials that you use.
Sorry, I didn't clear this up. Sean,
by charging water and still smell really strong like bleach.
Flyback,
makes sense.
My flyback is not DC. It's AC. So just so we clear that up, because we're going to have confusion with people and they don't understand this. It's an AC flyback, and you buy them as AC flybacks. So,
yeah. Cheryl brings up a good point. For instance, He's talking about a temperature difference as opposed to the actual temperature, and I wholeheartedly agree with that. It is all about the differential because what's cold is not necessarily cold. It's about where the barrier is, right? So where you have your torsion fields, right, that ultimately have a degree of containment, you need it to be much hotter on one side than it is on the other. That is the containment, the non-diffuse containment. So you're still always going to have some kind of permeation of diffuse heat in that case. That's context to heat, right? But it's never going to be proportional. You would expect a linear and gradient um, dispersion of the heat through the cooler environment. Anywhere that you could draw a line where it's, you know, yeah, 20, he's saying 20C. I mean, I don't know what that is in English. You know what I mean? But
Well, sorry,
yeah,
Canadian.
right. I mean, it's probably like 40 degrees Fahrenheit or something like that. It's probably in that 35 or something, whatever. I mean, if you have a 35-degree Fahrenheit difference between this side of the line and that side of the line, like that's what you're looking for. That's what to get your head around. So I mean, that's an excellent result. Right. That's an excellent result, Gerald. But that's the point to Sean is that this isn't about what's, having a cold inside. This is about the hot not getting out of the orb. That's what it's about. And how well you can even measure the accurate temperature or anything with inside that sphere is yet to be seen because you see the optical effects it has and all the means that we have of either capture data or emit light and reflect and then back or sound and back or any of this and that. It's all distorted by virtue of what we're observing. It's screwing up the light. The light's getting caught up in there and kind of dispersed in a sequence, if at all, and unproportionally to what you expect. It goes from high pitch, high frequency, high voltage squeal to silent. It goes from this to that. So everything that's doing is just kind of stuck in there. So how you can even get an accurate measure of what's doing is entirely, like I don't even understand how you can. I don't think you can. I don't think you can get a good measure on the inside of that. You'd fool yourself if you do.
I just think the fact that you'll see the different temperatures, if you can see it, is the main point. Regardless of what the number is.
Mm-hmm.
You know what I mean? I think that's what it is.
Just dead on, man. It's about a differential. It's about a differential.
Yeah. By the way, the DC flyback doesn't have a single diode in it. Just so you're aware of that. It has strips that are built up in a capacitor that work on the outside of a magnetic core. But that's neither here nor there.
Dennis says that you could tell by the metals it melts. No, you can't. Like if you need to understand something. It's contained, and that's the point. It doesn't have a diffuse relationship with the environment as far as we could tell. So, yeah, but I mean, you'd have to be putting something in there, and then you risk destabilizing it. I mean. You could tell by virtue, like if you were to ionize something and put it in, but then it's ionized, so you're going to have condensation regardless. I think that the temperature is so high that it wouldn't be measurable, frankly.
Well, what it's going to be able to do is check this out. If you create a second one, it's going to be able to balance between the two. You'll never get the first one to run over Unity, okay? And it'll never do self-run. It's just not designed to do that, okay?
Nope.
That's not it. You got to put a second one to it so it can balance itself out. Okay, has to be able to go to here, then go back to here, go over here, go back to here. Okay, and it has to have a yin and a yang. Okay, there's no question about that. Okay, that's exactly. It's like putting your rodent coil into balance to get unity. You have to have a cap bank on each side. If you don't have a cap bank on each side, it'll never go into unity. Okay, that's because you have two different coils going on. You have to be in unity. Okay. There's a difference between plasma when it gets to the purple state and it gets to these higher states of plasma, okay, as we're starting to see when you get past the laser state. than there is in a clear plasma. Okay, clear plasma more calm, more stable. You can't see it, but it's there. It's like what Gerald Cole put out. Okay, levels of plasma building up in between layers of static. Okay, it's the anode cathode relationship again. But yeah,
I couldn't agree with you more.
yeah,
It's by the way, and I'll put it out there. What Nathan just said is by virtue of in which it was created. So all you're doing is taking the same process that you used to create it in the first place, and then you're duplicating that. You're duplicating that process, and now you have two things that are in a relationship that have a habit, and that's exactly how it formed in the first place. And then when you create a second one, now you create a second habit, and then they were saying in the chat, who said it? What happens when there's three? Well, then you make a Malaysian airline disappear. But the funny thing about it is that once you understand that each one of these things actually has the inverse side of it somewhere associated, right? It's not disassociated. That's the point, right? It would seem disassociated because maybe you can't measure it, see it, detect it in regular way, but that doesn't mean it's not there, right? And the reality kind of is seeming to be that it is here. So as long as you bring it into our space and then you're able to project it out, there comes your result too. But as far as energy and stuff like that, and actually, upping the game, you Nathan's dead on. You just need to repeat the process again, because then it'll continue to react in that same way. But again, you got to remember something. When you have the two, it generally makes the third. And once you have that third, well, then there tends to be a coalescence, which is, again, how it forms, right? So once you have the third vector and it turns into the tornado, it collapses into the sphere again, right? It's just how it goes.
So I'm going to answer this question right here.
Yep.
Okay. And I'm going to do it by just showing you. There you go. So when you bash one of these up, this is what you find. Those little strips right there. That's your diode. That's your high voltage capacitor effect. There's just junky little things right there. That's it. There's no little black diodes in there. That's your capacitor as well. If you ever built a high voltage capacitor, there's your.
It's just copper, split copper foil.
That's it.
Pushed in between two pieces of plastic.
That's it. There's your magnetic core right there. That's the negative. So when you want to look at this thing, what's your negative on it? The magnetic core. What's the outside of it? A high voltage capacitor that has a wire coming down from each level that it goes onto. And that's your high voltage. So what is it when you go to convert it back? It's high voltage potential. That's the reason why when they tell you there's diodes in there, it can only go one way, because in those strips themselves, they cannot build in a high enough magnetic field to go the opposite way. That's why. That's why it's a misunderstanding of what the process is. You could say DC goes into it, but that's not what comes out of it. It's a magnetic core and it's a high voltage potential.
I always say to think in terms of frequency, and I know we always kind of do, but to step that aside for a second, let's just go more broad than that and just say energy. Okay, once you understand that how energy manifests is, and we've been think about how long we've been saying this, okay, but the context is now a little different, right? Energy only manifests, okay, in its relationship with matter. That's it. Okay, no matter, energy, no manifest. That's it. It has to be with matter. Now, that said, it's vectoring, and the direction and what it's doing is by definition what it is electromagnetically. Okay, so we've had a whole entire 3 hour long episode on that, right? It's like what it's doing defines what it is. And
Yeah.
once you realize that the geometry of different conductors and different, dielectrics, and different, insulators, okay, all play a role in balance. Okay, in conjunction with the vectoring is the effect. Okay, it's like creating a soup or something, putting all your ingredients in. So your ingredients are your vectors, but like how you season it, is the matter that and the electromagnetic properties of the matter that are in the equation, right? And that's what decides whether it's going to taste flat and bland, or like whether it's going to actually pop and be good. It's the seasoning you put on. It's sort of the best analogy I guess I could come up with at the moment. But yeah, that's sort of what it is. Like when you see something like that, you just got to look at it, how it's moving the energy, and what it's in relationship matter wise with, right? If whatever it is I'm throwing, the matter is throwing off a magnetic field, well, you understand what the magnetic field's doing already, because that's already got a fixed vector. It's got a half life. Okay, we call them permanent because they last longer than we do, but that doesn't mean forever. Okay,
No.
right.
Well,
So
half-life.
until you zap it again, then you zap it again, it probably
Yeah,
be fine.
then it
But
restarts it. Yeah.
right, then it restarts it again, because why? But that's in a state of like high efficiency, not perpetual.
But
High
that's the
high
thing.
efficiency looping. Feedback looping.
See, here's the problem. Everybody thinks that a magnet has to do with voltage and amperage, and it doesn't. It has to do with the radiation level. What you're doing is you're pulling in radiation from the environment when you're spinning a magnet. Just understand that. That's what you're doing. It's radiant, so it's not going to harm you, but it's not at the radiation level. But when you put it into a magnet, okay, it's there. Now, is
All
it
right, hold
detectable by
on.
your little
Quiet
thing?
part out loud. Quiet part out loud, real quick. Remember what I said about the poles before? Okay.
Yeah,
Well,
I get it.
when you have certain crystal arrangements, okay, that lend themselves to polarity, they form the poles, and then what you end up with is a north pole on the outside and a north pole on the inside, and a south pole on the outside and a south pole on the inside. But what did I say? It's inverse. Well, what happens when you create that null zone in the middle? It draws in the energy. So the energy perpetuates throughout the entire thing by virtue of the null zone in that case, because of the polarity that was initiated in the first place, because it had the prerequisites, so to speak, for the polarity to exist molecularly through its crystal structure. However, by inducing it with a current in the first place, threw it into a state of not perpetual again, right? Motion, not perpetual, but self-sustaining high efficiency motion, which then makes it semi-permanent,
But hold on. That's assuming the node's the same. See, I don't think the Earth node's the same as what we're talking about here. A regular node would have a vortex in and out, but I don't think Earth works the same way. I think it has multiple nodes in it. It's a split.
Oh, it
node.
could well have multiple nodes, sure. I agree.
Yeah, well, but it changes some of the ways that it acts and what it's doing. You know what I mean? Why it has multidimensional aspects to it. Why
Mhm.
why it could do this while still vortexing through the center. That's a split node.
It's like we said last week. I mean, if you upper dimensionally push out lower dimensionality, but lower dimensionality exists in great energy potential, and you allow that in, then you have it. It's there. So now it's just, if that's actually feeding the energy loop of the system, then that's feeding the energy loop of the system. Doesn't mean that it's forever. It's probably got a rate of decay,
Okay,
like
hold on.
everything else. Everything's got a rate of decay.
Hold on. We misunderstand this point so much. The center of the cosmos is all the energy that you could possibly have. Okay. It's going to build out in every single universe to every sun. Okay. It's going to build out until it builds back in to the center again. And then it recycles it back out to everything again. and then builds back. Why does it work? It's the same thing as a transistor. Transistor is over unity based on saturation. Okay, it is these two wires want to connect together, but in order to do it, this thing right here has to go down and fill it in, right? Well, this two is one energy level, but when I add the third energy level to put the saturation in there, it goes over the amount. So it's an amplification of the one that goes through. That's why it amplifies going back to the center. That's as simple as it gets.
Nice. Paul says that he believes that it's called the surf bird.
Oh.
Yeah, for 1 week it was. So we all voted that one down.
Oh yeah, that was.
We're like, we got to talk about this thing. I don't know. Like, can we? I give super credit to Sean because he's wildly creative, and I stand behind his work wholeheartedly.
Oh yeah, me too.
And like he's very like modest yet proud, but modest at the same time in that nice balance as far as like the work, the result, what it is, and then like he has that pride moment of like naming it something, and he's very but then we all looked at him like, bro, this is incredible, and we're gonna have to talk about this and experiment with it and research it and analyze it. We're gonna have to refer to this thing as a surfer just constantly, and then his wife was like, Sean, why do you call it a surfer? Evidently. Like, no.
Hey Sean, we gotta thank your wife for the new name, man. Because
that's it.
She didn't
like axed that one for us, thank God.
She vetoed that one on you.
Yeah, I love it.
No, Sean's a genius, man. There's no getting around that, bro.
Total genius, and
the way that he thinks, man, is on another level.
And the kindest person I've ever met in my life. God bless him.
Oh yeah, absolutely there. So,
yeah, Rav is way better. Yeah, I'm down with that. Rav is rad, man.
Oh man, right on, brother.
Yeah, so we've been seeing some weird stuff with this. The weirdness doesn't end. It coincides with all the science that you hear about.
Oh, it's going to get better too.
And it is only going to get better because we already understand what's going on. And part of this episode, since we are only 147 in, right? I wanted to kind of bring up a subject that I think is actually like maybe more so in Sean's case at this point than where Nathan wants to go with it, but also Nathan's too. But this ties right back into the first or second time that I was on, where I literally said these exact words paraphrased. Okay. I said, I firmly believe that materials science, okay, is the next step in it all. Okay. And that as far as any material science that I'm aware of at this point, my greatest interest lies and my most confidence lies in doped ceramics. Okay. And I went on and I built on it even at that time. And I said, because, like there's a lot of things that you could do, and it doesn't have to be just this, okay, you take the clay, you put this in it, that's it, right? No. It could be so much more. There's so much control. For instance, in my theory of what's going on with Sean's paired with like what would ultimately exploit it, right? Like I actually have written down here so I could not mess up, I guess, but what you would do is you would take a ceramic slit, okay? And you would dope it with different materials to give each layer a different attribute. But it actually goes further than what I'm about to say, and I'll build on it after I'm done with this particular example, right? But in Sean's, right, if you had one thin layer, right, and these are all thin layers, by the way, very thin, all right, of a ceramic that had high water permeability, okay, and high conductivity for like a base layer to face the cathode, okay? And then you had a layer above that that was a medium water permeability with a semiconductor electromagnetically, right? As the layer above that, and then you had a very thin layer of a good low permeability insulator. Okay, so you're now at that point you're controlling the level of moisture that can travel through, but without letting none through. But it's also an insulator electrically.
Okay.
So you're separating this from that. Basically, it's got a little leach, but not much, and whatever leach is going to be through the water, and that's the point. Then above that, what you would have is like a low permeability semiconductor that's high heat resistant. Okay. And then the final layer that would actually face the anode surface would be a low permeability, high heat conductor. Okay. So you'd be able to conduct the entire surface at that point without the need of an electrolyte. So you'd be able to get the anode to connect, start pulling through, still getting a little bit of moisture through, but mostly what you're doing is inducting the current to entice in Sean's case again, to entice the hydrogen through to then actually allow that to build. And what you'll find is that again, because if you do it right, okay, you wouldn't have to worry about the moisture level being what ultimately closes it off. It would build until it reaches the density level, okay, that then begins to stabilize. So rather than rely on the moisture being the catalyst, so to speak, of the reaction that causes the ball, okay, what you'd be relying on in that particular case is the density levels and the things actually wanting to self-form, which will happen. It's just a matter of the density level starting to leach into the next sector because the density level is too high and it's under a compression state by the anode. You get it, right? So it would still form, but it would form under a different premise, and it would form at its, natural and highest potential for whatever the setup is at that point, right? Mm-hmm. So by layering these things out, you literally control the moisture level, the permeability and advancement of the charged particles that are going through it. You could prevent the cathode from leaching too far into the anode and the anode from leaching too far into the cathode. Like you have a total controllable and customizable separation of these things that only come together under the conditions that you want. And you could even control the porosity of the size of the semiconductor on the anodic side to determine what the ideal circumstance for hydrogen plasma production in solid would be in that circumstance while allowing it to be pulled out. All right. So all of these things, there's a lot of experimentation to be done and a lot of configuration to be done. But a simple addition to a slurry of different types of ceramic allowed to dry, layer it up. This is what you get.
Well, let me ask you this, okay?
Yeah.
The reaction doesn't really start until you scar the surface. So if we just take a drill bit and scar the surface of this thing, we get the reaction probably faster. But then what if we took the Q-tip and doped it with different materials, okay?
Sure.
That'd probably give us the different reactions, right? Right away.
Well, it's funny. It's funny you say that because when you told me that you felt that carbon was like the primary reason that your shit was happening, my first intuition, in fact, I might have even said it, was I was like, well, get yourself a graphite blank, like a mechanical pencil blank. Just scribble on it with some graphite and then see what goes.
There we go. Okay, I'll try that.
I mean, realistically, that's all you would probably need, but there's a lot of different additions into the ceramic that you could add that add different components. And one that we haven't discussed is the fact that both you and Sean are using terracotta. Terracotta is super high iron oxide, super high. And all of my research has said that inducing the iron oxide to high heat current, even for a small amount, exponentially increases your magnetic component. So you're you're actually creating a dual polarity magnetic field when you're inducing it, which and so you're already encouraging everything to fall into place the way that it does.
Mm-hmm.
And that's by virtue of it being red. Somebody decided red was a good color for terracotta, that's what you're using, and that's what you get out of it.
No, try different ones, man. I'm up for that. And then put a little pencil shaving on the surface, or just writing on it. Yeah.
Yeah. You just get a blank, man. You get a,
I have to mention this, okay? Highlighter ink in water shows laser reaction. Okay. So you'll be seeing some of that in the future. I'll give it a shot and see if these things are actually lasers. It'll pick it up on that reaction. You'll be able to see it. Okay. I got the video, Sean. Give me just a minute. I'm going to put them up. He's got 3 videos for it with the infrared camera, so he was able to get it to work.
Awesome.
John, real quick, I just want to go over this. Okay. So you got to understand this. You have a bobbin with a magnetic coil. So just a coil wrapped around it. Okay. That's all you have. That's your negative. But without that outer plastic and that metal strip and that plastic and metal strip, that's your capacitor and your diode in the same part. Okay. If you remove that, you basically have an AC flyback out of both sides of that magnetic coil. That's what it is. Okay. If you want to make a DC flyback, you take that and cover that up with the plastic. Then you put a strip of the foil, then plastic, and then foil. Now, that means that the frequency and the field of it in the negative of it is just like an AC flyback, so it's very low. Okay, you barely got enough to get it to be airborne. Okay, so you're probably looking anywhere from, I don't know, 800 volts to like maybe 10,000. Okay, and then the amplification going on in that capacitor itself gets you up to 30,000 volts. Okay, so yes, that part is true. The problem that you come into when you understand this thing is that when you build a high voltage capacitor, there's no magnetic value in there good enough to build it backwards. It can't go backwards. It can't go back to the magnetic field. There's not enough magnetism in it. So anyway, I just wanted to answer that, and then we'll put up Sean's.
Now, Sean did say that these are old. Okay, so I don't know how old we're talking or what stage of it, but I guess let's look at what he's sending us, and if he feels comfortable doing it again, we'll tackle that. If and when.
Oh, I got to show this. There, look at that. There's your steady reaction.
I mean, what more do you want? That's absolutely non-diffuse. Look like it's ringed out. You could see the levels of compression that are occurring. You got to bear in mind when you're looking at this. If you have a wood stove, okay, in your living room, okay, and you throw a log in there, okay, it's a fraction of the temperature that this probably is in the center, okay. It heats the entire first floor of your house, but yet the throw on this is probably only triple, let's say, the surface area of the hottest point.
Yeah, it's got a different temperature differential in there. Yes.
Yeah, and it's separated like in rings.
Well, yeah,
that's non-gradient. Those are hard rings.
Okay, but that matches why we're getting that lens thing going on behind it. It's showing us exactly what it was telling us here. Okay, so it's the same thing, man. We got it right. Okay, it showed what this thermal camera just showed right now. It's the absolute answer.
Hold on. Note the self here. Okay, it looks like where he has the point, the cursor is on the red ring, which, mind you, the proximity to the core here, right? I don't know if it's reading 178 or 207 because I don't see what's to the left there, but regardless, you know it's not anywhere near 178 or 207. And it immediately drops off to ambient, like, which is it's looking like just over 50 degrees or 60 degrees, whatever, within a smidge of itself. That is exactly what we needed to see.
Yeah.
Because this is why the light doesn't get out, because the heat doesn't get out either. This is why there's not no light bleeding from it into the environment, but like a disproportionate sum. Because it's not that it's non-diffuse at all, and we've discussed this in the past. You can hold a lot in, like a lot, but that doesn't mean that it doesn't frill off. But there's your lines. There's no variation outside of a sphere. It's just simply a perfect sphere that builds out into temperature layers.
Sorry, I'm trying to do something real quick while we're doing this.
That is huge.
Oh, it is.
So the like that's amazing, is what it is.
Yeah,
Like
so-
I literally stuttered at how amazing that is. Within a fraction of an inch, you have hundreds of degrees of difference. Hundreds of degrees.
Okay. Sorry. Give me a second. Yeah, Gerald agrees with you on something.
Yeah, man.
Hold on.
And thank you, because you know what? This is what we've been saying all along, man. Once I saw the light situation going on, and I know what it's like welding, man. You know what we have in a welding shop? Welding screens. You know why? Because when you're across the shop, and it's a huge shop, you get blind if you look in that direction from all of the bleeding light from it. That's not happening here. It's just not happening at all. It never was. Black in the center. Okay. And I got to check out what you did most recently. Because I don't know. But I mean, if it was in the gas tube though, Gerald, for what it's worth, you only have a finite amount of gas in that tube because it's in a vacuum and it's concealed. So there's only so much density level that you could possibly even attain out of that, which would give it a different measurable result based on something that's being built up in open air, where more or less the potential is, it's huge. I think that might be a factor in that as far as what the visual difference is. But I'll have to check out what you posted most recently.
Yeah. Gerald said his camera would not pick up his infrared camera. Like, couldn't show it on the screen. But I wanted to see that image if he could just take pictures of it or something else on his last test. At least that's what I saw. So sorry, I'm doing like multiple things right now. Mission Control dropped some stuff in the chat here for you guys for some links. So you guys have so you have information on some of this stuff.
Very cool.
Thank you very much for that.
Yeah, man, drop it in.
When you go over to his what is it? Not comments, but the whatever, the post. He has a lot of good information he drops in there. So all right. So yeah, we got this one, we got another one, Joe.
I couldn't even imagine how it gets better, but let's go.
Maybe just different angles, or that's on its side.
Yeah, I gotta zoom in.
I can't zoom in. Well, maybe no, I can't. That's when it's running. You took it from a distance. Yeah, he's getting his warning on there, like he said he would.
Yeah.
He took the other picture right after it turned off.
Well, I don't know what the capture rate on that sensor is, but one thing that I can say is that chances are when it pulses, it's probably really, really, really not good for it. That's what I'm assuming.
Yeah, look at how small his little cavity is right there when he starts this thing. Very, very small. Interesting. So, all right, we got one more.
So note about the cavity. When that cavity forms, though, there is like I said before, there's what's called like a sinting process, like a temperature that occurs within the clay structure, and when it sinters, what that means is that the porosity of that certain area actually closes off. Now that should make it impermeable, but it doesn't. You see, it actually makes a transversable cavity, which is interesting because it's sintering realistically should be taking the particulate matter and actually fusing it at the more or less atomic level, almost into a pseudoblast. Okay, but that's not what's being observed here. So it's very interesting because it's overcoming that despite having the channel. So these are all things to bear in mind because again, we're talking about temperature. The temperature is of the anode. It does go into the clay, but only really the outer surfaces, and then projects diffusely inward. And that's what, in Sean's case, is allowing for that plasma to create a draw. And there is a cathode bias there that leads to the electrolysis of the water. This is what's happening. So, is this another video?
Yeah.
Okay.
So, you can see you put the water on it.
Yep.
Okay.
By the way, people, sharpen your cathodes. I'm so like it gives me heartburn to think that you have square cathodes.
This is cool because you're showing it build out to get to there.
Yeah. Well, that makes sense. So the anodic plasma discharge and arcing is too hot for it to, that's when it's forming. But that warning goes away as soon as that orb is formed.
Well, he has it off right now. That's the temperature that's going on the clay right now.
Oh, okay. I can't see. Well, I mean, see, that's the thing. And this is where we need the improvement. And I'm just saying this is not a criticism. It's just where we need the improvement.
So there's
this does nothing for us without the simultaneous synced up orb. Like for us to get the extractable data, we need that. Like we don't need one thing. We need all the things at the same time. So, that's just, again, it's not a criticism. It's just a matter of like moving forward. Things got to be done different. This is how they got to be done, or else we're not going to get the data we need. I know, Sean, it's not a criticism, and I'm sorry, at all. It's just like, again, when we do these things, we just need to be able to match up the data to know what it's doing.
No, so I think Sean's doing great, man. He got us these pictures right away. I think it's cool that he shows that putting the water on there.
Yep.
And the temperature of it because it cools it down. So that means the yellow layer is fairly cool. So even when he turns it off, that yellow layer is there. So look, you see it right there. You get the warning. You see the yellow layer in there. Remember, that's what the water layer showed. And you can still see it just pushed it out. So he's getting definite hot and cold right there. That's for sure.
Yep. Sean, you knocked it out of the park. And
even the anode.
You've knocked it out of the park, man. That's it.
Oh, yeah.
And aside from knocking it out of the park, having what Nathan's doing right now in these other stages is showing the missing parts of what yours is actually already doing kind of in a different way. Well, in the same way, but to a different level of stability.
Mm-hmm.
the thing is, like, you can't tell what's going on in this thing. This is the best insight that we've had so far beyond the visual pulsing and seeing the environmental changes as it, is doing its thing and everything. It's this is the best data that we've had so far on yours, but then Nathan's actually is showing what happens before you build the walls up so tight that nothing can get out, because now you're seeing all the geometric patterning and coherence that's going on within it.
I think Mike's only gone for 1 week, Gerald.
Yeah, he went to Calgary this week, huh?
No, dude. Yeah, he's been sending out the short videos of him out and about and getting tours and doing stuff.
Hey, you know what? Maybe you need to do Old Man Builds After Hours and throw invites out to the same old, the usual suspects there.
There you go. Yeah, we could.
Yeah. Mind you, Sean, something. Your work is absolutely incredible. Beyond, and nothing I'm saying is a criticism of the work at all. All it is we know that between us, what we're trying to accomplish here, there's just got to be that clear way forward, to make sure that the data's like the data sets are all usable and everything, and that's what the talking points I'm bringing up are. They're not out of frustration or anywhere bad at all. It's just a matter of like, there's affordable ways to overcome some of these things, and we'll talk about it, as far as what it all means. All you got to do is scratch up, like, for what it's worth, you just scratch up old people's cell phone, like people's old decent cell phones with good cameras. And as long as you can get that, you can just sit there and take 7 different videos at a time of the same exact thing, all hooked up to a tripod.
Mhm.
That's all you really got to do is monitor. And as long as there's Wi-Fi, you don't have to have 7 cell phone plans. You just transfer it via Wi-Fi to a Dropbox, and then you can consolidate it all. There's a ton of ways to affordably do this.
Yeah, well, Sean and I were talking about a camera. He was looking into the same camera that I have, and I asked Joe recommendation on lenses. So we're going to be able to figure this out. Just work as a team to get it. You know what I mean? I picked out 2 lenses, and hopefully, fairly soon I can pick those up, and then we can get into really what we're doing, because I need a telescopic lens, and then I also need one that goes for dark time. And I don't know that they have dark and telescopic. We're gonna have to look at that, but I don't think they combine that well. So the thing is the distance from the experiment and how it plays with your camera. With some of this high voltage, it'll zoom in and out all day long, so you have to correct that. Joe already told me that. But yeah, there's a lot of stuff that'll be done here, and then eventually, will it be put into probably a box? I would imagine it would, so you can get out all the outside conditions to it. You know what I mean? And then eventually, could you vacuum chamber it? Sure, you could. You know what I mean? Because you're going to need to, because I'm sure this thing would build out even bigger and more beautiful in a vacuum chamber, because you're not going to change the resonance in it.
I mean, I'm starting to question how necessary it is. I think that the beauty of it is that it doesn't require one. And I think that the efficiencies are still achievable right now with what we're doing. Thank you, Darren.
Oh, right on, brother.
Everybody that's tuning in is going to be a member, and that's what it's about, man. It's
right
that's
on.
what it's about. Get the seat. Now we got to put stuff up there too. I know you do, but like we got to get the good stuff in there. Make sure that everybody's taken care of. So,
thank you, Darren. I appreciate that, brother. Right on, man. Yeah, we got what? How many is that today? We got 15 Old Man Builds memberships that went out today, man. You guys are totally awesome. Dude, yeah. You got to cover everybody.
no, this is the way. We have a sea of green in the chat. That's what I love to see.
Yeah, I think, you know what? The vacuum is important, because if you see how it builds out in space, you understand the size dimension. Just think about that. We're doing an open air. As soon as you pull a vacuum on it, everything gets to like double to triple the size or more. So you can use a giant vacuum chamber to do this.
Yeah, but how does that affect the expansion, the compression ratio? It doesn't.
Well,
I don't think it does.
no, I
It,
think it's all preset.
right. So I mean, the ratio of the expansion to compression doesn't change. But the one thing that does change in a vacuum, I suppose, is the resistance of that particular force. But the other thing that changes, for what it's worth, okay, is the amount of what's being pushed out. Now, I mean, obviously, we could say ether, and I don't disagree with that. I'm all in on ether. Like, convince me otherwise. But aside from shoving potential, you know, there is a real effect, so to speak, of pushing potential with shit attached to it. Which is why getting hit by wind is not the same as getting hit by a wave at the beach, right?
Yeah.
It's kind of, there's a density difference there, right? And that's sort of what it comes down to. You get hit by a wave at the beach, you know it all day. you get hit by a gust of wind, you might be like, what the hell? But
But the advantage to putting it into the vacuum chamber is the amount of distance it grows from the original size outward based on the pressure, so that they can actually see how much bigger it'd be in space if you created the same thing. You know what I mean? So it might be like a little pin drop here, but maybe in space it's like, baseball. You know what I mean? Or maybe a softball or something. Who knows? But that's the reason why you would want to do it to there too, because you want to know how it built out in actual space.
Yeah. By the way, I want to express one thing, and I know I kind of already, maybe I beat the Stead horse, but I got to beat it some more because of really how exuberant what was just shown with that infrared was. Okay. You saw it here first, folks. Okay. And you know what? I mean, there's other people doing it. I'm not saying that there's not. And everybody does it in their different ways. Okay. But as far as air, atmospheric, in air, that reaction, okay, non-diffuse. You saw it here first. That happened here first. It happened today here first. Okay. And Sean did it. And that's that, and that's credit where credit's due, because he did it. That's it.
Yeah.
But all the things that we've been talking about, and like my whole big word 60-second shit bang that I'm gonna try to put out there in a week to raise a couple more eyebrows and gain a little bit more exposure on this, to try to gain a little bit more traction, to maybe try to get the, maybe somebody wants to put up testing equipment for us or something. Like try to get something going on here where we could like show it bigger and better. What was just shown today is the evidence. That's it. That's all the evidence anybody needs. Because, like I like to say, well, things don't do that. You see, things don't do that. Look at something that's 700 plus degrees with that same exact camera. Look at the ambient environment, pull back from it. You have a huge diffuse, wobbly, entropic situation that is simply not present in that whatsoever. It's gone. Guess why? Because you separated your differentials, you brought them into a state of equilibrium, and then you move them around each other without combining them. That's why. Because guess what? That's what reversing entropy is. When you take all the cold out of the hot and the hot out of the cold, and then you have them over here next to each other but not mixing together, well, what'd you just do? What do they tell you in science class? You hear this, physicist? This is why we get upset. This is why we get frustrated. Because, saying the quiet part out loud is this system, by virtue of its initial configuration and the way that it brings it together, it reverses entropy. Okay? Like, that's plain and simple. But you can't reverse. Yes, you can. Well, no, yeah, you can. And And I'll
They
tell
just
you what,
don't understand it yet.
you're right. Yeah, you can. How do you do it? The way I said. How do you do it? Yeah, with the memory. That's how. You have this two different things going on other sides, and that's sort of it. Well, you can be sorry all you want, but I'm not sorry.
Yeah, I'll be honest with you, man. Because this thing is so mobile and the way it's done, it's going to be real fast in figuring this out in physics. You know what I mean? There's and the fact that you could chamber it and it'd probably give you even a better reaction on some of it. You can not chamber it and run it. You could get the cameras closer once you chamber it because it'll pull it apart more, where you could see everything a little more clearly. I think there's so much here, man. And if we can get two of these things to lock, man, it's game over. I'm sorry, you won't have an invention better than this. Okay, unless you could pull off anti-gravity before I do, you won't have anything better than this. Okay.
Yeah. And I'm not trying to make this like a Target thing again, but first of all, Gerald, I mean, the fact that you showed that 4 days ago, I think is awesome.
Yeah.
I mean,
on it, yeah.
but to be real, I don't think anybody here is viewing this as like a who did it first or dick measuring contest or anything like that. I don't really think that's what it is. It's the same goal that we're all kind of setting out to achieve, and we're all playing whatever role we play in it. Like, for instance, I would be doing these experiments myself if I was set up to do so, and I'm just not. So I rely on them to do it. But they show me things, and it's like, well, what's going on? And we talk about it, and well, what ends up coming of those discussions is the realizations of the things that we're discussing here. And if you already know it, that's cool, but we're trying to bring it out to a greater audience that is seeing these things and that they hoped and dreamed of and believed of, and then
Yeah.
bringing it to life and then explaining why. That's what we're here to do. So it's not about who had it first or whatever. And I kind of say it with respect, and I do, because I truly respect you. But just because Sean's been sitting on those. The first thing he said in the chat is that these infrared things that he never shared with either one of us, by the way, were old. AKA, he's been sitting on that, thinking that, well, it didn't really show anything because it got blown out because it was too hot. But that's why I was like, no, share it. Case in point is, it doesn't really matter what happened first. The idea is this thing has existed however long it's existed, as long as we've been working on it. That's as long as we've known about it, because our opinion of it hasn't changed since we first saw it. Once we saw what it was doing, we kind of understood where it was at. And it went very quickly from self-organizing plasma to understanding its property. So that's where we're at right now. And, there's no competition here. This is all of us trying to do this. We're all shooting for the same thing. And we're doing better than people with billions of dollars of funding. So,
yeah. Well, I just say this. Sean said he made it open source, so just mention him. And by the way, we'll do that every time. You know that from us.
We haven't withheld really any information about what we've discussed behind closed doors.
Yeah, we're all trying to do the same thing, man. Oh, sorry, can't put that up. Sorry, didn't read it first. Yeah.
Well, okay. I mean, again, I said I didn't see your experiment. I'm not going to go back and forth with you, Gerald, on this, but at the end of the day, I said I didn't see your experiment. I don't know exactly what it entailed, but the last that I knew that you were creating this similar type of effect,
Dude,
with a different circumstance. So
who gives a crap? We're all just putting it out to the
public. We're all just talking about it.
Yeah, who cares? Look, it's all open source. It's all put out there, and if we make a few physicists unhappy or a little nervous, I'm happy. Okay, give them a reason to take those numbers and put them to good use. Okay, we're all good.
They're right. There's no friction, because at the end of the day, you got to remember, not only do I like you as a person, and I love your work and always have, but we have enough enemies. You know what I mean? Like there's a whole group of people that don't agree with us.
Yeah.
Like even if we're mildly not on the same page on certain subject, mildly, we agree 99.9% of the time on most things. Do you know how many people don't agree with anything we say, no matter what you show? We have enough enemies. Like
I got a couple of those. Dude, we let one in the members area and he disliked the video. We got a troll in there.
I'll tell you what, that guy could suck my fatty until he shows me reverse entropy, okay? Until he could show me how he could virtually contain heat in thin layered portions up until like a super non-diffuse state, then he could just like literally like suck on my nutsack. Like fuck that guy.
Yeah, we're not talking about Gerald, by the way. Gerald,
No. Whatever troll.
Somebody totally different. By the way, let me say this. I don't know how you not like Gerald. Like, dude, it's just fun. It's the best time I've ever had learning is when we all get together and just shoot the bull. Oh my god, dude, it's fun. Sorry, I kind of miss Ben too, man. Where's Ben? Where is he hiding at?
Yeah, for real, man. Listen, I mean, I need a little Ben in my life every so often, and it's just complete absence. But
okay, hold on. Let's see if we got a Ben thing. We'll just play it. Oh man, I know I have it somewhere. We'll do a little Ben action here.
And just remember, Gerald.
Hold on.
The cats love you, but I never pissed on your router.
Oh, you gotta love it. Oh man. Oh, I love that move. Oh my god, it reminds me of American Pie. You remember when he was dancing for that hot chick?
Oh yeah.
Oh man, Ben, we love you, man.
Come back and laugh for us, Ben. Please laugh for us.
Oh, it's so great.
But you got to turn your video on. I'm sorry. That is the criticism.
What's up, Papa Bill? Papa Bill got some cool stuff going on his channel right now, Joe.
I've seen some of it, man. I follow Papa. He got the spinny things going on his table. That's what he got.
Oh, dude, he has that Utron thing, man, and he's got it spinning. Oh, dude, that's cool as heck. Yeah, and then he was telling you the difference between self-run and, you know what I mean, the capacitance, everything. That was a cool video, man. I love that one. I caught that one the other day.
Right on.
Yeah. Ben, just dancing, dude. Nothing. Yeah, Ben rocks, bro. I gotta see, because he said he was gonna be on Fridays and he didn't. He went to the one and that was it.
Well, you just gotta remember something, right? The Rav and the Rave are only one letter off. When you go to a rave, what do? Is you make a sphere, right? Is that no? Sorry, that's like super corny dad joke there. That's like bad.
Yeah,
like not edgy at all. It's not innuendo at all. It's not dirty. Nothing.
We're gonna have to work that in. What's up? What's going on, Lulu? We're gonna have to work in.
Wow, we got everybody and their mother.
When we do the chicken wings next time, we'll have to call Lulu, by the way, and have her, like, you know what I mean, help us with that. Well, not that you have a burnt mouth, but mine is. And then we'll have to put on some Ben action when we're over there, some Ben dancing while we're doing that and slurping down our Slurpees on the next one.
All right, listen. We could talk about another special, but I think we really, really should do one very, very soon. I don't know that it should be chicken wings though. I think that we need to level up a little bit. Maybe do virtual barbecue status. Do a long cast. You know what I mean? Where we're just kind of virtually hanging out at each other's barbecue. Everybody with us. Call out the chat the entire time.
Well, Limited State hooked us up, man, and I'm sorry I don't have it right now, but there's a link to Discord.
The Discord, right? Yeah.
You set it up on there so we can all turn on our cameras or not turn them on, and all get in there and say whatever you
I'll
want.
tell you what. As soon as I'm off this cast, I'm finding that Discord. I'm gonna join it, man. I don't know. I don't know how I missed out on this, but I did. I heard about it.
Yeah, he set it up for me, man. He hooked me up, and he's going to help me out in getting things straightened out so that I understand them better. I haven't had a chance this week to go back in and look at it, but we talked, man. Let me just tell you, it was an awesome conversation. I had about an hour and a half with him to talk.
I love it.
We went over a lot of things, man. It was really cool. So the Discord on this channel is going to be out of sight, man, with everybody in the chat.
And you know that's been the main thing, I think, that has kept this from erupting with our community, because we have the best people. We really do. The people that are in our chat, the people that watch constantly, these are the best minds in this area, you know, and to be limited to communicating, you know, when we're live in a chat in that context is really, really, you know, suppressing the amount of advancement, you know, that we could have all together at any given time, and that sort of thing. So you know, I know that the biggest challenge has been like, I see somebody in the chat and they're lighting up my mind, and I'm sitting here live, and I'm like, get in touch with me on Facebook. Like, you know, it's rough. You know, like I had to put out like my whatever information on myself that on the internet, you know. But with that, you can just bypass it. You just join the Discord. Here we all are, right?
Mm-hmm. Okay, I'm looking for it right now, guys.
All right, you go do that. I got to take care of my dog for 1 second. I'm sorry for all the interruptions today.
Yeah, not a problem. Just give me a second, guys, because I sent it to myself, and then God, I got so many things in my email. Oh, here we go. I found it. All right, that didn't take but a minute. All right. All right, here you go, guys. And I'll tell you what I'll do, man. I'm gonna get some food for the family and stuff after we do the show, and then I'll pop into Discord myself. So, yeah, there you go. There's the chat right there's the link right there, and then we'll all pop into that one, man. And hopefully it still works. I'll have to double check. Right on, man. Okay. 3 of them. Yeah, well, we're gonna have everything on this channel, man. So, you know, share the ideas, whatever you got, man. Whatever you want to open source, feel free to. So, Joe, here I put it up right here.
Awesome.
We'll go in there right. Well, you know what? Let's go in right after the show. Check it out.
I was gonna say, so you put it up at like 2:32 around there. So I'm gonna go back after this, go and grab it. You have the link. You'll send it to me on Messenger or whatever, and we'll do it, yo. After show.
Yeah, I don't even know how to get in here and put it on that link. Look at me go. I'm such a rookie at this.
Sean, thank you so much. I hope you enjoy what time you have left at your beautiful lake house. You know, enjoy every minute of it, man.
Oh, look at that. Lulu's already here. Papa Bale. Rage Fire. Sorry. My voice is being.
I want to say that my name on Discord because I don't remember. I feel like it's Electric Hot Tuna. Okay, so if you see me on there, I'll be Electric Hot Tuna.
Sorry, I had to turn it off. Everything's coming through my ear. I'll have to pop back in, guys. Sorry. Huh. Oh,
Okay.
I see you guys in the papers. Nice.
Yeah, when we're murdered out because we showed the goods. Stop.
Nice. He said, Limited State says he's here and people are joining.
I love it. Blow it up. Make it as big as you can. And remember something, if you have like a key point that comes out of a discussion and it's meaningful, like, post it on the Discord too. I'm sure that there's probably a function there where you could actually document, aka chat or whatever, a feed or something,
Yeah.
aside from just going on there like live. If there's something great that comes out of it, you want us to know about it, I guess put it in there and I'll just monitor it. We'll bring it in. We'll bring it into the discussion. Don't let the discussion end when the lives end.
Yeah, it's cool, man. Sorry, I keep hearing things in the back of my head, man. It's that thing. I opened up a different thing, so I hear all of it. Sorry.
All right, Nathan, I'm gonna say it, man. Do you know how excited I am to go on that show where they're looking for what we're doing and we're doing it? And I'm gonna sit there and be like, present it as a theory, and then when they ask me a question, that's probably gonna be some naysaying ass question. My answer is gonna be, "Oh no, we've already done it."
You'll love
Did
that.
I say this was a theory? I'm sorry. I mean that. Do you want to see videos?
Yeah, you already got it. Nice.
Yo, you know how awesome that is, bro. It's just like totally like walking into the room and just being like,
Well, you know what? You kind of have to put together some kind of a presentation if you get the longer show. You know what I mean? As
well,
far
I
as
mean,
which order to put things in, and
absolutely, but like, mind you, something. If we go to if we make it onto the longer show, and I'm not saying me, I'm saying we, right? Because all that does is put me in direct communication with them to arrange for that next time, right? And what that means is that I could explain to them that no, well, it's me, but it's a team, and like
Mhm.
the team will come on, and we could discuss this as a team, and uh, so we could arrange it at that point. We will have an arrangement. The idea here is that we want the word out, we want it known and said, but at the same exact time, we also want to do it smart. We want to do it well.
Mhm.
And realistically, to sit there and show the best of the best of the best and all the results and everything like that, well, I mean, we're not there yet. That's plain and simple. But that infrared says otherwise. That
Yeah.
infrared says otherwise. All right.
Well,
And
I think
all
if
we
we
need is proof of concept, because guess what? I'm pretty sure they've mentioned before that they're willing to throw out funding, for the stuff that makes sense, and I don't know what their ability or what their connections are, but you know what? Might as well feel it out.
yeah, well,
Yeah.
I think one of the next steps on this too is to have Bob Greener look over it and see his opinion on it. You know what I mean? Since he's gone so far into that thunderstorm generator, something like this may really interest him. So
Bob, if you're out there, open arms,
yeah,
warm welcomes, mild personality deficiencies rather than total narcissistic, delusional ones. Um, you know, like, right. Bob has always been and always will be welcome on our show.
oh yeah,
And he's a great mind. He really is. He really is. And honestly, like, I don't really claim to know all of whatever dilemma that's going around with Thunderstorm Generator right now. To be real, if it was total fabrication, like as far as like everything was concerned, I'm in shock. Like, I really am. I believed in that thing. Like, that makes me question my reality.
well,
You know what I mean?
hold on, because I know the original worked when the original inventor did it. Okay, and this one supposedly works. I think they're manufacturing problems, and I don't know if it's just to that extent. And there was some hairy stuff to go along with it, but that's not for me to tell you. That's for Bernie to bring out because he said he was going to do a video on it. So we'll have to see what he has to say. But
Well,
I agree. I
I'm
agree with you.
interested I've been following that thing for years and years and years and years. And if anything, it was my first introduction into this as far as like any sort of greater understanding was concerned, about how it works. Because once I cracked the idea of how that works mechanically and I saw the mechanisms at play, like I realized that you could apply that just across the board, and it's always worked out for me. You know what I mean? It's always worked out for me, which is why that if the fundamental thing that taught me what I know, doesn't function, then it's like that's like sadness. But that doesn't mean that everything that I've come of it is incorrect either. And that tends to be that the learning experience of that, for what it's worth, is like the Graviflyer, man. Like, your Graviflyer taught you everything that you needed to know, right? And in my side of the equation, the thunderstorm generator kind of taught me everything I needed to know, as far as like whether I was working with it or not being secondary, worked differently.
Dude, I gotta say this, okay? Jack Safari, Admiral Jack, was over there on Alien Sciences channel, and I caught it. He was telling him that the warp bubble that you build would both hold in energy and push it away, and then it'd be mostly radiation. Oh my God, if he didn't just describe exactly what I created over a year ago. Okay. I'm sorry, guys. I've already had his technology. I don't need his patent, nor will I ever. I already have it. Okay, because I built it. So let me just tell you this, man. Sorry, buddy. You can go through all the channels you want. I've already had it and put it out there. So you're just, I don't know, farting in the wind. It's already done, man.
Nathan, man, you just schmuck, bro.
Dude, I could show it doing it too. I could, you know what I mean? That's the thing. It's like, it's not just all numbers.
And I've said it and I guess this is a little bit maybe it doesn't sound related, but to me it is, right? See, like my whole entire life I've struggled personally, okay, with like not really understanding why I skip from like one thing to another. Like I have all these broad interests, right? And like I go and I do something, and when I do it, like it's like full throttle, right? And it's like I get to a certain level of mastery, and it's never the highest level of mastery. I'm not going to say that it is. I get to a certain level of mastery, and then like I never move on from it. Like I never let it go. I never become disinterested or disengaged. I just simply progress it into something else, and then that something else that I do, becomes, even if it's not seemingly related, it becomes like this continuation of these other things that I've done, and then I reach a certain level of mastery, and then I kind of leave it where it is and move on. Now I could always go back to these things because I've reached a certain level of mastery. It just simply is what it is, right? Mm-hmm. But the idea here is that like by never focusing on one thing all too much, but like learning a whole lot of things like deep in and doing it, it gives you like this different vision, and that I think that's sort of what I'm kind of describing here. And like that's why the few tend to resonate, okay, with what we're doing, what we're saying, etc. Because it's only through that process of this deep passion and being able to move away and on, but never on from, right? It's only through that process that you can understand enough things fundamentally and at a deep enough purpose to become like, and it's not self-proclaimed, and I hate to pat myself. It's not like that, but like you become a polymath, and what you end up realizing is that you have these broad spectrum of interests that you're all deep into, and that you related one to the next. And, the better you learn how to write and learn what language means and these things, the better you paint, and the better you paint, the better you imagine, the better you think of how the flow of it all goes. It's all tying together once you have enough, but most people never venture that far. Most people just like country music and breweries, you know, like country music and breweries and, you know, football and shit. And, you know, then they work and that's their life, you know, like football and work and breweries and country
Yeah.
music.
My life for a long time. Yeah.
And there's nothing wrong with that. It's just stuck is the point. You know, and maybe you have one hobby. Well, I like to metal detect. Therefore, I know a lot about metal detecting. Okay, cool. So that's what you did. But that's it, right?
Yeah.
Pretty much. See, when I started metal detecting, what I found was that everything I found that I needed to know about. Right? So I'd pull something out of the ground and be like, what's this? Well, now I need to know about this chain. When did they use these chains? Oh, they used them then? Well, I mean, how did they make these chains? Who used them? All of it. And then, oh, okay. So wait, now where did I find it? Wait, I found it here. So I found this chain that was used on a horse carriage thing here in this location, and it's from this time zone. What was going on here at that time zone? Do you see where my mind goes? And that's the problem.
Yeah.
It's the problem and the solution, you know? So
Yeah,
it's like, you're right. I know it was off topic, but it's just a train of thought for people to follow up
That's
to
not
what
good.
it takes to be able to do these things. You know, like to be able to look at something and be like, I see.
Yeah.
Yeah.
The more you can relate to, the better. I found that true myself.
Yeah, all right. And Elijah says, it's no problem. Yeah. I tend to agree. But you know what? From the outside perspective looking in, it just looks discombobulated.
Of course it does.
It looks like total chaos. It looks like 1 second you're into this, the next second you're into that, and you were so good at that. Why didn't you stick with that? It's like, but because I was so good at it. Get it?
Yeah.
I
Didn't
know
have
I
to
could
really
do
work
it.
that hard
It
to
was
do
fine.
it. Yeah.
Right. I know I could do it. It's fine. I did it.
No, I get that too.
Yeah.
All right, Joe.
So
We're gonna get out of here and get onto that Discord, guys, and then I'm gonna make my family dinner. So,
right
all
on.
right, guys, I want to thank everybody that came in and watched us today, man. You guys have been awesome. Ulysses, thank you for the 10 memberships, man. You're so awesome, brother.
And Darren also, man. Thank you for dropping them.
Yeah, 80X, man, got a free month. There you go. Right on, man. And then Darren's got the 5, man. You guys are totally awesome, man. We're gonna have everybody that views this show as a member soon. So,
Yeah, and I'm gonna make you a promise, and that means that I'm making a promise for Nathan too. Because guess what? I'm invasive like that. we will get you a backstage between the two of us today, and we'll try to keep it to a manageable length. Okay, dense and manageable. All right, but that's only for if you're green. All right, so if you're not green, get green. Right,
Right on.
yo, Wahoo, I'm looking at you. Come on, it's like $3, bro.
There's the Discord link one more time. All right, guys.
All right.
Thank you very much, and have yourselves a great night.
Peace and love.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. wheels of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds,